So we've almost got our basic functionality working. The last step here is we need to clear our purchase and our mixture labels, and as well as reset them to 0. So how are we going to do that? Well, let's go into start day button pressed, and we can go ahead and update our lemons to purchase, and we can set this equal to 0. And let's also set our ice cubes to purchase, and we can set that equal to 0 as well. We're going to set our lemons to mix equal to 0, and our ice cubes to mix to 0 as well. And finally, we want to go ahead and just update our main view at the end here. So this is important because we want to go ahead and make sure that the labels reflect these changes. Specifically, we're going to set our lemons to purchase, our ice cubes to purchase, our lemons to mix, and our ice cubes to mix, which you can see here are these labels and these labels here back to 0 after we press the start day. So let's go ahead and see if this fixes our current bug. Let's go ahead and rerun our app here. Let's go ahead and add 1 here to each one of these. Now let's press start day, and we see that it's now resetting these items to 0 when we press the start day button. Specifically, it's going to go ahead and call the function start day button pressed, and it's going to, at the end of the for loop, reset these values to 0, and then we're going to update the labels by calling update main view. So it's very important that we call the function update main view. Congratulations on finishing the first part of the assignment. We're now going to get started on the second part of the assignment. So the first thing we're going to be doing here is we're going to be creating a multi-dimensional array in order to store our weather info. And we'll have a dynamic image to display the weather as well. We need a way to represent weather throughout the day. This isn't the most sophisticated approach to modeling weather, but it does allow us to play with multi-dimensional arrays, which is really important to understand. And it's a pretty cool way in which we can show our weather images off. So we're going to go ahead and we're going to create a property here, and we're going to call this weather array. And this is going to be an array inside of an array, so we have to do double brackets here. And inside of the 2 brackets here, we're going to write int. And this is basically to say we're going to create an array of arrays, and they're going to contain integers. So let's see how this works. So let's go ahead and create our first array here, and we're going to say -10, comma, -8, comma, -5, comma, -7. And let's go ahead and create our second embedded array here. We're going to say 5, comma, 8, comma, 10, comma, 9. And let's finally create our third one here. We're going to say 22, comma, 25, comma, 27, and 23. And let's just take a look at this for just a second here. We're specifying that the variable name for this array of arrays, right, is going to be weather array, and we're specifying that it's going to hold integers. And what we're doing here is we're creating an array on the outside here, and we're saying inside of that put 3 other arrays. So our first array contains 3 numbers here, or excuse me, 4 numbers. Our second array contains 4 numbers, and so does our third array. And we notice that we're separating each one of these with commas because there's 3 elements inside of our weather array, right? 3 different arrays inside of there. So hopefully that's not super confusing. You're able to take a look at the previous videos. If you are still confused by embedded arrays, hopefully practicing it here will also help you figure out how to use them. Now, each one of these internal arrays is going to represent a weather pattern for a single day. So we're going to have 3 different days with 3 separate weather patterns. And this is going to be a nice way we can group weather patterns for a specific day. So just imagine this is day 1, this is day 2, and day 3. Day 1 is pretty cold out. Day 2 is a little bit warmer, and day 3 is still warmer yet. So let's go ahead and we're going to create a second array here. And we're going to simply say that this is going to be called var weather today. And we'll say that this is going to hold an integer. And we're going to set this equal to 0, 0, 0, 0. And what this is an array. I'm just going to add spaces. It's all right to add spaces here. And this array is going to hold integers. Its variable name is weather today. And we're just going to be putting in one of these three arrays so we can figure out what the current weather today is. So we're also going to hold that as a property, so we don't have to keep accessing the information from weather array. We now want to create a function in order to simulate the weather for today. Specifically, we want to be able to access one of the arrays inside of our weather array and set that equal to weather today. All right? So we're going to update the values to be, not 0, 0, 0. We're actually going to give it some weather. So let's go ahead and scroll to the bottom here. We can create another function, and we're going to call this function simulate. So it's going to be func simulate weather today. And let's add our parentheses and our curly braces. And inside of this function, the first thing we want to do is we want to get an index, and we want to randomly pick one from our array, right? We don't always want to grab the first day from our array or the second day or the third day. We want to randomly pick one of these three. So how do we do that? Well, we're going to use our famous arc for random, and let's go ahead and make this constant, excuse me. And we're going to say let index equal int, and we'll say arc for rand underscore uniform, and we're going to say that we need an unsigned integer here, and remember that this is a 32-bit integer, so we say uint 32. And what number should we pass in here? Well, let's make this dynamic in case we change our property up here. So we'll say weather array dot count, and what this will do is this will ensure I need one more parenthesis here. This will ensure that I'm always going to be randomizing based on the count of the weather array here. And it looks actually like I'm missing one more parenthesis at the end there. So that should resolve the error. So the next thing we want to do is we want to index into our weather array and set it equal to our weather today array. So let's say weather today is equal to weather array, and we'll index into it. We'll say index. Now, this might seem super confusing, so we're going to actually scroll back to the top here, and we're going to figure out what's going on here. So what we're doing here is we're saying, give us a random index based on the number of elements in my weather array. So right now there's 3, so pick a number between 0 and 2, right? 0, 1, or 2, so we can index into index 0, 1, or 2. And once we get back that random number, we're saying, okay, give me back randomly one of these 3 indexes, or excuse me, one of these 3 arrays. And with that array, we can set that equal to weather today, because weather today is an array that holds integers, right? So these two types will match up perfectly. So hopefully embedded arrays aren't super confusing. Just remember that in Swift, we can only have one type. So don't try to put an array of integers and then an array of strings. So the final step we need to do in this video is to actually go ahead and use this functionality. Now, hopefully you can guess where we would initially want to set up the first weather for our project, and that would be in view.didLoad. Right? So right above main view, update main view, we can go ahead and say simulate weather today, and this will set our project up when we first load our project up with an initial weather. However, every day or every time we finish the day, we want to go ahead and update the weather. We want to change it. So where would be the other place we would want to call the function simulate weather today? Well, that would be in the start day button pressed function. So let's go ahead and locate that. And again, right above main view, we're going to say simulate weather today. And we're doing this above main view because we want to change the weather before we update our UI. Now that we're able to update our weather today array, we want to be able to average the different temperatures or integers inside of our weather today array. In order to do that, let's create a function so we can reuse this functionality. And in order to do so, let's scroll to the bottom here. And I'm going to go ahead and use that func keyword again. and we're gonna call this function find average. It's going to accept an array, and this array is going to be holding integers as a parameter here. We're going to call this parameter data, and it's going to return an integer as well, right? It's going to return the average. So the first thing we want to do is we want to create a variable in order to start adding all of the values in our array together. So we're going to say var sum is equal to 0, and we're going to make this a variable because we're going to be adding values to the sum. And then we need a for loop here, so we're going to do for x in data, right? We're going to be iterating over the array of data, and the values inside of the array will be assigned to the variable named x. So we're going to be able to say sum plus equals x. And what is this doing? Well, as we run through our for loop here, we're going to get the first value from our array, and it's going to be equal to x, and we're going to add that to our sum. And we're going to iterate through all of the values inside of the array that we're going to pass in that's named data. And we're going to be able to get the total sum of all of the values inside of our array using our for loop here. Then what we're going to do is we're going to say var av, or we could even say average, and we're going to say that this is going to be a double is equal to double sum, right? We're going to convert our integer here, right? It made the default to an integer, and we were going to convert that over to double, and then we're going to divide that by double data.count, right? So we're going to divide the total sum of all the elements in our array by the number of elements in our array, specifically the data array. We also want to account for rounding, so we can write var rounded is equal to, let's actually specify this as being an integer, and we're going to set this equal to int, and we're going to do ceil, and then we're going to put average in there. And oh, I need one more parenthesis, and then finally we're going to return our rounded number, and we can remove these additional returns here. Well, the ceil is kind of a special function here. It's actually part of C, and we have access to it in Swift as well, and this is basically going to round up. So not strictly necessary that we use this. It's, you know, just an introduction to a cool new function we can use if we want to round up when we have a double here. So what we're doing here is we're basically going to convert our double into an integer, and we're going to return that integer since that's what we specified for our function find average. Finally, we want to go ahead and we want to call or use this function find average. And what we're going to be doing, instead of using 10 potential customers, we're going to use the average of the weather to limit our random function when we go through and press the start day button. So let's go ahead and locate that. And basically what I'm saying here is we're going to replace customers. Instead of just being 1 through 10 or 0 through 10 here, we're actually going to use our function instead. So let's first go ahead and create a constant above customers, and we're going to say let average equal find average. We're going to use our function here, and then we can pass in weather today, right? That's the value or the array that holds the current weather of today. And we could use the self keyword here. This would be completely fine to do self.weather today, but we don't need to. Again, weather today is a property, so we could use that self keyword. And then we're also going to go ahead and update let customers. Instead of setting it equal to this randomizer here, let's go ahead and change this to int arc for random uniform, and we'll do uint32, and we'll pass in our average. So right now, sorry, one more parenthesis. So now what we're going to do here is we're going to get a random number back from our randomizer here, And the parameter we're going to pass in is our average, and we're going to get our average based upon the average of the current temperatures inside of our weather today array. So this makes our customers a little bit more dynamic based on what the weather is outside. Now we need to show the weather to the user, so he or she can make an informed choice on how to spend their money. Fewer customers means he shouldn't invest much in lemon and ice cubes. And in order to show this, we're going to add a UI image view in code instead of using it in the interface builder or adding it in the interface builder. And what I mean by that is we won't be adding it in the main storyboard. We're actually going to be creating a UI image view dynamically in code. So if we remember here, we had an image view we could search for here. We can also create these things in code, and we're going to be practicing that in this part of the solution. So in order to do this, the first thing we want to do is we want to create a property, and we want to give it a default frame. And what I mean by frame here is if we select any of these items here, we can take a look at the frame of where this label currently is here. Now we might have to move some things around our storyboard depending on how this UI image view gets drawn, but we'll worry about that later. For right now, what we want to do is we want to create a property. So let's do this underneath our weather today array. And we're going to say var weather image view. And we're going to specify that this is going to be a UI image view. And we're going to set this equal to UI image view. And for this, we need a parameter of frame. And I need to make sure that I use the correct case here for UI image view. And we're going to do cg rect make, and we're going to pass in 20, 50, 50, 50. So what's going on here? Oh, I messed up UI image view up here as well. That's why this is throwing an error. So what's going on here? Well, the first thing we're doing is we're creating a variable, and its variable name is weather image view, and we're specifying that its type is UI image view, and we've used this type before in the storyboard when we've gone ahead and dragged in image views, and we're able to set the image property in order to present, photos on the screen. The next thing we're doing is we're creating a default UI image view, and the reason we have to do this is in the past this was done in the storyboard. By dragging it in, we were able to create a default instance of UI image view, and we were able to give it some sort of rect. But now we actually have to specify where on the screen it should be drawn. Now, this doesn't mean that it will be drawn yet. We're actually going to have to do that in just a second. But this is basically saying that this instance knows that when we go to draw it or go to add it onto what we say is our view, we're going to be able to add it at the points of 20, 50, 50, and 50. Now, again, let's just review what's going on here. We have labels here, right? And we see that X, Y, width, and height. And this is 4 different numbers. So this corresponds to the X, the Y, the width, and the height. We're right now specifying that we want to draw this at X is 20, Y is 50, the height is 50, and the width is 50 as well. The other thing we're doing here is normally when we connect these things up, we get an IB outlet, right? And we're able to check out the connections and see that this is hooked up to the storyboard. But we see here that we're not adding an IB outlet, and that's because there is no reference to an item on the storyboard, right? We're actually going to go ahead and create this UI image view instance ourselves. So we actually need to tell the computer program that it should add this image view to what we say is our view. So let's take a look one more time at our storyboard here. And we see that we have our view here, right? And this is default. This is our white background here that we have. And we're able to add a bunch of labels and buttons on top of it. So in order to add our image view, we actually have to add it to the view. And we can actually access the view. We get access to the view by default inside of view did load. So let's go here and we can say self.view, and we're going to call the function add subview, and we're going to add our weather image view. And that's going to seem a little bit funky, but what we're basically saying is access the view that we saw on our storyboard and add another image view. An image view is a type of view here. So we're able to say add subview and basically add it on top of our view. And where are you going to add it? Well, you're going to add it at the points I specified here. Now, in order to specify the frame points, we haven't talked about this yet, we're going to be able to say cg rect make, which is going to allow us to create a frame for our image view. And this allows us to encapsulate 4 different points into a single, what we say is struct. We've covered structs before, that allow us to, encapsulate all 4 pieces of information together here in order to set the frame for our UI image view. So the other thing that you're going to see here is we're using the self keyword to access view. Now, I recommend doing this. I think you can remove this and this should be fine. But when accessing the view, it's customary to use that self keyword to do so. So I recommend using it. You're going to see this in a lot of code, self.view, add subview. You might just see view, add subview, but I like to use the self keyword. And then remember that for image views that they're type of view and that we can pass it in here, even though it isn't just a regular view, it's a special type of view, we can add it as a subview. So we could also add a UI button here. We could also add a label here as well. And actually one final little adjustment. Let's go ahead and just move the simulate weather today. I'm just going to Command X is going to cut. I'm just going to drop that in. I want to add my image view before I update the weather. So order really matters in computer programming. This is kind of a really good time to take this aside. If you do things in the wrong order, your computer program isn't going to work properly. Kind of like in a recipe, if you were going to bake bread and you added the yeast to the wrong point, the bread wouldn't rise. In our computer programs, we really need to pay attention to order. And generally you want to do this UI setup first, and then we can update our weather here. So I'm going to keep it in this order. And what we'll see in our next few videos together is that by adding my image view first and then calling the function simulate weather today, I'm going to be able to update the image view, and it's already going to be on or available to me on the screen. Whereas if I flip this, I'm going to be calling update on an image view that hasn't been added yet. So it's better to add it first because we're going to be updating the function simulate weather today in order to update the image view's image property dynamically based on what the weather is today. Every time the weather is simulated, we need to update the image to reflect the weather. Before doing that, we need to add 3 different images for each forecast. The asset catalog is the correct way to add images to your Xcode project. I've included a link to the guide if you want to take a look at more information about adding images via the asset catalog, but we're going to go over this together. And basically what this is going to allow us to do is correctly set up retina and non-retina images for our project. So we're also going to be able to organize them very nicely inside of the asset catalog as well, and we'll practice that too. So the first thing we want to do is we want to download our image assets. I've already gone ahead and downloaded them, and I put them on my desktop. We see that they're called Lemonade assets, and we have cold, mild, and warm. But we're not going to drag them in the way we have done in the past. What we're going to do instead is press on images.exe assets, and this is going to open up the asset catalog. And the first thing we want to do is we want to set up what we call image sets. So we're going to go to editor, and we can go to new image set, and we're going to call this cold. And we also need to add one for mild and warm. So we're going to go to new image set, and we can call this mild. And let's create one more, and we're going to call this warm. And now we need to actually add both the non-retina, this is the 1x, and the retina 2x for our image assets. So how are we going to get those? Well, let's go ahead and shrink Xcode a little bit and go back to our assets here. And the first we want to add is our cold at 1x. So make sure we have cold selected again here. And I'm going to go to cold.png, which is the non-retina one, and I'm just going to drag that into the 1x. You can also import them if you go into Xcode editor import, but I like to add them this way because then I don't get all these other images showing up inside of my XC assets. I think this is a little bit cleaner. So we're going to do the 2x next, cold at 2x. We're going to drag that right to the 2x here. And let's do our mild next. So we're going to do mild.png and our mild at 2x. Now, if you make a mistake, you can just select it and you can press delete, and then you can redrag it in. It's no problem. And we're also going to do warm here. So let's do warm.png and warm at 2x. And we see that we get these nice previews of these, image assets that we have here. So with these all added, we can go ahead and expand our Xcode again. And just, take a look at the XC assets, the asset catalog. It's pretty cool. It's a really great way to organize all your image assets. And it's the proper way of handling your image assets. So definitely worth taking a look at. Right now, our weather patterns are rigged. The first pattern of the array is cold. The second is mild. And the third is warm. Using this, we can easily deduce which image to use for our weather by using the random index chosen in the simulated weather today function. So we're going to find the simulate weather today function. That should be near the bottom. And we're going to go ahead and add a bit of code here. We're specifically going to be using a switch statement here. And we've seen these before. We're going to say switch index. And we're going to say case 0. And we're going to go ahead and say weather image view dot image is equal to UI image, and we'll do named, and we'll say cold. And our second will be case 1. We'll say weather image view dot image is equal to mild. So we're going to say UI image named mild. And finally, for case 2, we're going to do weather image view dot image is equal to UI image named, and we'll say this is warm. Now remember that we need a default case. This is required for a switch statement, so we can say weather image view dot image is equal to UI image named, and we'll set this default to be warm. So for some reason there's not a case here 0 through 2, which should not be the case based on our current code, but if for some reason we changed it, the default would be warm. So right now what we're doing is we're going to be able to update our UI image view, specifically the weather image view's image property, with the appropriate image. We're just creating a UI image instance using the UI image function, and we're able to pass in the parameter cold, mild, warm. It's important that we get these correct based on the names of the image assets we added. And remember that the index, the switch statement, is going to change based on the index here. We have 3 different potential numbers we could get for our index here. It could be 0, 1, or 2. And we also have our default case here, which is if it's not 0, 1, or 2, the default would be implemented, which would make our default image warm. So let's go ahead and run our computer program here, our application, and make sure that the weather is now being implemented properly. So if we take a look at our application, right off the bat, we see that we have a little bit of an issue here. And that's that our images are currently not showing up on our screen here. So our code doesn't appear to work. And what the problem is here is even though our image assets came in as cold underscore or lowercase cold, lowercase mild, lowercase warm, when we dragged them in, they actually got switched over to be capitals. And we can confirm that by taking a look here. It's because we named our image assets here to be cold and mild and warm. By dragging them in, we've actually renamed these things. So if we go ahead and switch these all to cold, mild, and warm, this would work. We could also go back and rename our image sets here, but let's just go switch them. So keep that in mind. I kind of purposely built this in so that we would get this bug here. And if you use capitals for your naming conventions, that's fine in the .exe assets file. But if you leave them as lowercase, you're going to have to make sure that you're using the proper case here. So just go, over and double check. You can click on these and, make sure that you're using the proper name. And that would be a quick way you could debug it. So let's go ahead and rerun our application here and see if our assets show up. And in fact, we now see our sun. Let's see if we can get one other thing to show up. So let's buy a little supplies here. Let's set up our mixture. Let's start our day, and we now see that mild is now appearing. So we are able to rotate through our weather as well. We're going to get started with our brand new project. So we're going to create a new Xcode project when we have Xcode open here. And we're going to choose iOS application, single view application. We can choose next. And let's go ahead and update these fields here. Usually I have these updated already, but looks like I've been playing around. So we're going to call this project Taskit. And the organization name is going to be Bitfountain for me. Now, if you have your own organization, feel free to drop that in. If not, you could just even use self. It doesn't really matter here. The organization identifier, again, we're going to use our reverse DNS here. So I'm going to do .io, .bitfountain. If you have your own website, feel free to drop that in here. You just do like com. Whatever the name of your website is, or bitfountain.io, whatever URL you want to use. And if you don't have one, you can just use self.edu. The language here is going to be Swift. We're building this course out in Swift. Our device is going to be universal, which is going to allow us to deploy to both the iPhone and iPad. So as part of this project, we're going to be going over auto layout, and we're going to see how we can use auto layout to stretch our views so that they'll fit into both the iPhone and iPad. We are not going to check the option to use core data because we're going to figure out how we can add that boilerplate code that would be generated if we did select this option ourselves, right? So we're going to be adding code that would be generated normally when we check this option. In future projects, we will be able to check this option. But for now, we're going to figure out what actually is Apple generating when we do select this option. So we'll have a deeper understanding of how to implement core data and what kind of core data is in the background. So we're going to go ahead and select next. I'm going to check the option to create a Git repository on my Mac. So let's make sure we select that. We can press create. And we're going to have a brand new project here named Taskit that we're going to be able to start building our task list project in our next series of videos. So now we want to get started setting up our storyboard here. I'm going to go ahead and just close my right pane here. And my left pane, just give myself a little bit more space. Actually, I'll leave my right pane over here. But what I can do, if you actually need additional space, is you can close your scene outline. I'm going to leave that open because I have enough space to see my view controller. But if you're running out of screen space, totally understandable if you need to do that. For right now, what I'm going to do is I'm going to add a table view to my view controller here. And we'll talk about what table views are in just a second. The other thing I'm going to do before we talk about table views is I'm going to embed my view controller here inside of a navigation controller. So I'm going to make sure that I have my view controller selected here, my scene outline, and making sure that you have the proper UI element selected in your view controller scene is a really good way to make sure that you're not making mistakes, both when you're connecting items and when you're just selecting items inside of your storyboard. Sometimes just clicking around, you can click the wrong UI elements and it causes all these sorts of problems. So with the view controller selected, we can go to editor and choose the option to embed in navigation controller. Now we've done this before, but one thing I do want to point out is that we now have this arrow here. We've had this in the past, but we have our navigation controller selected in our scene here. We see in our attributes inspector, so you don't have that open, you can select it now. The isInitialViewController option will be selected, right? We're gonna have a check next to this. Now, if for some reason we went over to our view controller and we checked the option for isInitialViewController, we would see that that arrow would jump over here. And basically what this would mean is our project would start with our table view instead of starting with our navigation controller, so our nav bar would not appear. So if for some reason your arrow gets moved and you don't see that nav bar, you can always just make sure that the isInitialViewController is selected for your navigation controller. So you can also drag that graphically, if you're using a bigger screen. The other thing you want to do here is we want to take a look at our table view here. So our table view in a real simple term is just a way we can display multiple rows of information. If you think about your address book, if you have an iPhone or if you've ever picked up an iPhone before, you notice that there's many rows inside your address book, and each contact is its own row. Well, that's a table view, and table views are really useful when we need to display a lot of information. It's really common to use table views inside of applications, so we're going to spend quite a bit of time going over table views, how to set them up, and because there's a degree of complexity, we have a few steps to set these things up properly. We're going to figure out how to reuse table view cells. So if you have a contact list that's like 5,000 people, we don't keep generating 5,000 cells. That would eat up a ton of memory. So what we're in fact doing is we're going to figure out how to reuse our cells over and over again, how we can customize the cells to look the way we want them to look without like the Apple defaults, and how we can properly implement or interact with our table view in terms of touching things, swiping things in our table view. We're going to see that we're going to get a lot of this functionality for free, but a lot of it we also have to set up properly in order to get that functionality from Apple. Now it's time to do a little bit of resizing. We're going to be using the iPhone 5S or the iPhone 5 for a lot of our initial testing. Now I know the iPhone 6 is super popular. If you want to do some resizing to get there, it shouldn't be too hard to figure out what to do for that. And then we will be adding auto layout, so we'll be displaying to all interfaces in the future. But for now, we're going to work on the iPhone 5S and 5. Super popular, a lot of them out there, so we're going to stick with that. We are going to want to resize our table view here so that it fits on an iPhone 5S screen. Right now, this view is significantly larger than an iPhone 5, right? The screen would look like something like this. So we're going to go to our size inspector here, and we're going to go ahead and we're going to change the width to be 320. That's 320 points wide, and that will properly size the iPhone 5 and 5S. The other thing we're going to want to do here is we're going to want to add a table view cell to our table view. Now you might be saying, okay, where do I find that? Well, it's in the object library here. I still have table view typed in from our previous search for table view. But if you remove that, between our videos, maybe we're taking a little bit of a break, go ahead and just type table view in, and you should see table view cell appear here. So you can just drag a table view cell in. And the table view cell here allows us to pick like a default table view cell. We're going to be able to adjust it in the future, and we're going to be able to reuse this thing over and over again to display lots of information on the screen. Now let's do a little bit of customization to see if we can get our table view cell to appear on our simulator. Spoiler alert, it's not going to appear until we do quite a bit of additional work to properly hook this thing up. But for now, let's go ahead to the attributes inspector and change the background color, and we can go to other, and let's just choose like a yellow here. Any color will really do, but I'm just going to use yellow. The other thing we want to do is we want to see if we can change the height of our table view cell. So what I'm going to do here is I'm actually going to select my table view, and I'm going to go into the size inspector here, and I'm going to change the row height to 75. Now let's see what happens when we run our application in the iPhone 5S, and this should boot up your simulator. And when this thing runs, we're going to see we have a table view here. It has multiple rows. There's many rows here. We can scroll up and down on it. We get that functionality for free. We also see that our row height is being properly reflected, and that's because we changed the row height of our table view. So our table view is properly displaying, but we see right now that all of our cells are white. This yellow table view cell that we set up in our prototype cell here is not being reflected in our simulator. So in our next series of videos, we're going to figure out, okay, how do we actually get this yellow cell to properly appear inside of our simulator? In this video, we're going to figure out how to conform to the UI table view data source and UI table view delegate. We're going to start to understand what this means, although to fully understand this, we're going to need to write our own protocol, and this will have to happen in the future. And we're also going to figure out how we can gain access to some functions that are automatically going to be called by Apple in order to set up our table view properly. So in order to conform to the UI table view data source, and that just basically means that we're going to be able to get access to some functions defined in another class that will automatically be called by another class. we're going to add a comma after the UI view controller, and we're going to say UI table view data source. And this is going to allow us to gain access to two additional functions that are going to be required, as well as some other functions that we can implement if we want to. Now, by required, we actually have a compile error here, and until we add these two functions, we will not be able to build our project or run our project. So the first function we're going to add, and we're going to find this by starting to type in table view here, it will automatically list out all of the UI table view data source functions, and we can see that most of these are involved directly with what should my table view look like. There are a few exceptions in here. Can edit row at index. Are we allowed to edit this specific row? But right now we're going to be taking a look at the cell for row at index path function, and we're also going to be taking a look at the number of rows in section. And this is going to allow us to define the number of rows that should appear inside of our table view. So, should we have 5 rows, 20 rows? So whatever we return from this function will be the number of rows we're going to return. And the cell for row at index path tells us which table view cell we should return at each row. So this function is actually called multiple times if we have multiple rows inside of our table view. Let's start with number of rows in section. We can go ahead and just press return. And we're going to see that we should return an integer here. Let me just close out this panel here so we can see this full function. And we see that this function is named table view, and that it gives us access to two parameters here. The first one is table view, which will be the table view we're going to set up. And then the second one is going to be the number of rows in section, which returns an integer value. It gives us access to an integer value here. And this basically tells us which section we're taking a look at. So table views can have multiple sections, and each section needs a certain number of rows. So we could say something like if section is equal to 0, equals 0, return 5, which would give us 5 rows in the first section. And we could say something like else if section equals 1, which would be our second section, go ahead and return 3, which would give us 3 rows in our second section. That's kind of how we could use this parameter of section. Notice that this function returns an integer, so we're going to say return 0 for now. We're just going to say, okay, we don't need any rows in our table view until we have more time to fully set up our table view. The second function we want to implement, let's go ahead and start typing in table view again, is going to be cell for row at index path. Let's go ahead and return here. And this function will return an instance of UI table view cell. You can find that over here. And we can see that we get an access to its index path, which is of type NS index path. And we also get access to the table view we're setting up here. Now, index path is pretty cool because it is a way to encapsulate both a row and a section. So in our previous example, I said something like if our section is equal to 0, right? We start with section 0, which is the first section in our table view, return 5. So as this is being called, the cell for row at index path function is going to be called 5 times for our first section, which is section 0, and index path dot section will be equal to 0, and then index path dot row will be equal to 0, 1, 2, 3, and 4. Then for our second section, we said, okay, the second section, which is section 1, will have 3 rows. This will again be called, and this time index path dot section will be equal to 1, and as we iterate over the 3 rows, it'll start at row 0, and then go to row 1 and go to row 2. So right now we need to return an instance of UI table view cell, and for now we can just return a default instance. We can say UI table view cell and add parentheses at the end here. So we call this the UI table view data source, so we can actually just add a comment here. We can say UI table view data source and add a return here. And this is the way we can gain access to this functionality that we're going to be able to use in order to properly set up our table view or define how many rows it should have, what it should have in each of its rows in terms of the cell. And then we'll be able to customize the cell later on as well in terms of updating the text it has. You could theoretically update the color. There's a lot of customization you could do, and you can make it different for each row if you wanted to using control flow. Now we're also going to add an additional protocol that we're going to conform to. So we're going to add an additional comma up here, and we're going to type in UI table view delegate. And down here we're going to be able to say table view, and we're going to find the function did select row at index path. And we don't need to return anything from here, so we can just cut the code. And let's go ahead and add a comment here. We can say UI table view delegate. Let's add a return here. And let's take a look at this function. Now this function is called when we tap on a specific row in our table view. So did select row at a specific index path. So again, going back to our example here, if we had two sections and we tapped on the first row in the second section, index path would be equal to, or index path.section would be equal to 1, and index path.row would be equal to 0. We tapped on the second section's first row. So we are able to access or figure out which row is being selected in our table view. So this gives us some interactivity with our table view. We also gain access to the specific table view. So if we had multiple table views, we'd be able to figure out which table view was being currently interacted with. So we've properly set up both of these functions for our UI table view data source, which were required. And we also added an additional function that is not required, but we got from our UI table view delegate. Now let's just quickly talk about protocols here. Remember that protocols are defined in another class. Apple has created the UI table view data source class and UI table view delegate class. And both of these classes define this protocol, or both of these protocols, and they add some functions, and Apple is going to be responsible for figuring out when to call these functions and how to call the functions that we're implementing here. Now we can help trigger these functions, specifically the UI table view data source functions. We'll see this in the future. We can tell the table view it should refresh itself, but we're not going to explicitly call these functions ever, right? We're never going to say, self, table view, and then like pass in number of rows and sections, so on. We're going to allow Apple to call these functions from these other classes, and that's the idea of a protocol or a callback. When another class is calling back to the UI view controller instance that we have here, the view controller class, in order to get some sort of functionality to run. In this video, we're going to figure out how to give access to the UI table view delegate class and the UI table view data source class. We're going to give it access to the specific view controller that we want to be calling these functions in. So specifically, we're going to give it access to viewcontroller.swift, right? Which is where we've implemented these functions. Right now, we're conforming to the UI table view data source protocol and UI table view delegate protocol. But neither one of these classes has any idea that the view controller exists. So in order to give it access to that, we can actually go into our storyboard, and we'll go to main.storyboard here. And what we're going to make sure to do here is to select table view in our view controller scene. Very important that we select this. And then holding down on the control key, we can drag from our table view to our view controller here. We can let go, and we're going to select data source. And then we're going to hold down the control key again from our table view to our view controller, and we're going to select delegate. Now let's make sure these items are selected. We're going to select our view controller here, and we're going to go to the connections inspector. And we can see that our referencing outlets now have our data source and our delegate set to our table view. So what this is going to once again allow our table view protocol, or the table view delegate class, to do is to actually call these functions. We're going to say, okay, you can actually call these functions inside of this view controller. So that's what we're doing when we're connecting this up. To give you an idea what the code might look like, if we were in view did load, we'd write something like self.tableview, or we could just do table view. We don't really need that self keyword. We could do .data source is equal to self. And we do like something like self.tableview.delegate is equal to self. And we don't need these semicolons at the end. That's Objective-C. So what's happening here? Well, we're going to remove these two lines of code in just a second. I'm just showing you what it would look like in code. We're actually just hooking this up in the storyboard. But what we're doing is we're accessing the table view's data source and delegate properties, and we're setting it equal to this specific view controller. So this, once again, I'm just going to keep hammering this home. This can be a little confusing if this is the first time you're using delegates and protocols, is we're just giving the UI table view data source class and UI table view delegate class access to this view controller. In this video, we're going to set up a custom class to manage the prototype cell we added to our storyboard. And we're also going to set up a unique identifier for our prototype cell so that we're going to be able to access the cell from our storyboard in our code. Let's do our first step first. We want to go to File, New File, and we're going to create a brand new class. We're going to choose iOS source Cocoa Touch class, and we can choose next. And we're going to make this a subclass of UI table view cell. Now, normally when you have many different cells, you can leave table view cell at the end of your class name to really make it a good identifier. But since we're only going to have one cell, one real prototype cell in this project, we're going to make this a little bit simpler, and we're just going to call this task cell. Just a simplification. If you wanted to, you could call this task table view cell. That'd be completely fine as well. So what we're doing here is we're going to say our task cell is going to be a subclass of UI table view cell. So we're going to add some additional functionality to the base UI table view cell. And we are not going to check the option to create a nib file or zib file. Zib and nib are pretty much used synonymously. And what this is this it allows us to create a graphical interface, a lot like the storyboard, that we'd be able to drag in a cell and manage it there, but we're managing our cell in the storyboard, so we don't need to create a zib or nib file. We are going to choose the language is going to be Swift, since we're building our project out in Swift. If you're building your project in Objective-C, you could drop down and choose Objective-C here. So we're going to choose next, and we're going to make sure we have our target selected here. We can press create. And this is going to go ahead and generate a task cell. Now we see we're immediately going to get access to some default code here. It's going to add two functions, awake from nib, and it's also going to set selected. So it tells us set selected allows us to configure the view for some selected state, and awake from nib allows us to add some initialization code, kind of like view did load in the view controller. Now we're actually not going to need to use either one of these functions, but we're just going to leave them there. It's the boilerplate code Apple's generating for us. And awake from nib, if we added our own zip file, we'd want to use this awake from nib often. What we are going to be using this for is we're going to be adding some of our own labels in the future to our prototype cell in our storyboard, and then we're going to be able to connect those up the same way we've done for other UI elements to our view controller, but we're going to be connecting them here to the task cell in a future video. Now, what we do see is we have this class keyword. We've seen this before we made classes, and we see that our class name is task cell, and that it is a subclass of UI table view cell. We're also importing UI kit. Since this is a UI element, we're immediately just going to, by default, import UI kit. So we're going to go back to the storyboard here, and let's select our prototype cell. We can make sure that we have our table views selected in the view controller scene here. Always nice to make sure that you're selecting the right UI element. And we want to update the class that's managing this prototype cell. So how can we do that? Well, we can go to the identity inspector, and we see there's a box here and it says custom class. And what that allows us to do is it allows us to update this prototype cell in our storyboard and say, I want to manage this prototype cell with the task cell class I just created. So we can go ahead and just enter task cell class in here, and it should autocomplete the way it did for me. If for some reason it isn't auto-completing for you, you can hold down the command key, you can press Shift and K, and it'll clean your project. You can press Command B, and that should rebuild it, and then you should be able to get the autocomplete here. So if you don't get an autocomplete, there's probably something going wrong. Make sure you're just using the correct naming convention. Make sure that you subclass UI table view cell as well. So now our prototype cell here is being managed by the task cell. And what that means is in a future video, we're going to be able to connect items from our prototype cell here up to that task cell class. The final thing we want to do in this video is we want to add a unique identifier to our prototype cell. So let's go to the attributes inspector, and we're going to see identifier here, and it's going to say reuse identifier. And we're just going to enter my cell in. Now, if you had a bunch of different cells, and my cell wouldn't be the best identifier in the world. But once again, we're trying to keep this project a little bit more simple. It's our first introduction to table views. So we're just going to use my cell, and this should really stand in real contrast to all the other code we're writing. Hopefully you'll remember that my cell identifier we're adding in this video when we use it later in our code. And what this is going to allow us to do is it's going to allow us to access this cell from our storyboard in code, and we're going to be able to reuse this cell over and over again as we add a bunch of different cells to our table view, right? So rather than adding 20 different prototype cells, we're going to be able to reuse this cell and just add different information on top of it. So we'll see how that looks in the future as well. It's now time to get our cell to show up on our table view. So in order to show that this works, we're going to be updating two of our UI table view data source functions. We're going to start with the number of rows in section, and we're going to return 5. And this is just, we're going to display 5 different rows on our table view. We're hard coding this for now. Later we'll make this dynamic based on the amount of information we have in an array or the amount of information we have stored in core data. The next function that we want to update, which is a little bit more involved, is a cell for row at index path function. Now we know we want to return an instance of our task cell, but we want to use the task cell we set up inside of our storyboard. How do we do that? Well, we're going to do var cell, and we're going to say that this is going to be a task cell instance. So we're going to specify that, and we're going to say table view dot dequeue reusable cell with identifier, and we're going to pass in the identifier my cell. So hopefully remember that was the identifier we set up in our storyboard here as the identifier, right? It's going to be the same thing. These two need to match up. Now, one thing that we need to do here, we actually have an error, and that's we need to specify that the class of the cell we're going to get back from our storyboard here using the identifier my cell is going to be a task cell. So we're going to do space as task cell, and this is going to go ahead and fix our error here. So what we're saying here is that we know that the type or class of the cell that we're going to get back from our storyboard is going to be a task cell. So we can specify that as task cell. Our computer program has no way of figuring that out. It can't just go into the storyboard and be like, okay, you set up task cell. It would be great if it could, but right now we have to help our computer program along by specifying this as task cell. Now we can update our return here, and we can return our cell instead of just the default instance of UI table view cell. And if we go ahead and rerun our application here, we're going to be able to see that our yellow cells now appear inside of our table view. Now let's take a little bit of time and go over the code we just wrote, and let's go over the functions we're using, right? We haven't really fully figured out what these functions are doing. So the first thing we're going to do is we're going to take a look at our first function here, table view, and we see we have a parameter here, table view, and it's of class UI table view, and we also have number of rows in section, and this gives us a parameter of section which is of type int. Well, what this allows us to do is it allows us to access the table view that's currently being set up. So if we had multiple table views, for instance, we'd be able to say, okay, which specific table view are we accessing? So we're passed in the table view as a parameter here. Generally, we don't use this, but it is available to us. And then we're also get the number of rows in section, right? And we're passed in the section. So if we wanted to specify two different sections, and we'll do this in the future, we could say something like if section is equal to 0, return 2, else, return 3. And then obviously we wouldn't have this last line of code here. And basically sections start at 0, and we can have a multitude of sections. This else would say, okay, we only have 2 sections, right? If we're in the first section, return 2. If we're in the second section, return 3. We can go ahead and just remove that. We're not going to be using that, but that's kind of how we use that section parameter. Now in our second function here, cell for row at index path, we're passed in both the table view once again, and we're also passed in the index path. And this time we actually use the table view parameter, right? Now this is the same table view as saying self.tableview, where we could explicitly access our property that we set up here. Right now we're just using the parameter, and this is a good example of when a parameter name would be the same thing as a property, and if we want to specify using the property, we could use that self keyword. But we're just going to access the parameter we're passed in here. And once again, if we had multiple table views, it'd be great to use this because we could be sure we were using the right table view here. Now we're going to use this function dequeue reusable cell with identifier, and what this is going to do is it's going to say, okay, let me go ahead and return a reusable cell that's specified in my storyboard as my cell. Now, what do I mean by reusable cell? Well, I mentioned before that we're not going to keep generating these cells over and over. We generate one, and then we're able to reuse that and just update the information on our table view cell. So this leads to a really efficient way to generate table view cells. And it's really important that we use this function dequeue reusable cell with identifier. Now, it would technically be valid to just keep creating task cells over and over again. We could keep returning new task cells, but this would not be a memory efficient way of doing it. So when you're setting up your cell from cell for row and index path, you want to remember to use dequeue reusable cell with identifier. Now, if hypothetically we had multiple prototype cells, we could use this index path property to say something like if index path dot row is equal to 0, right? If we're accessing the first row, use the first prototype cell. And then we could say, else if index path dot row is equal to 1, use a different one, and so on and so forth. In our case, let's go ahead and just add a print line statement here. So we can say print line, and we're actually going to be able to say index path dot row, and we'll actually be able to see that index path dot row is called, right? This print statement will be called 5 different times, and it's going to start at 0 for the first row. And so let's just take a look at a simulator. This is the first row, this is the second row, this is the third row, fourth and fifth. But this is index 0, index 1, index 2, 3, and 4, right? For row 0, row 1, row 2, row 3, and row 4. And hopefully that sounds a little bit familiar. When we were using arrays, right, they were also 0 indexed. So this will lead to consistency between our arrays and our table views when we're using table views to supply the data inside of an array, right? These two types of indexes will match up very nicely for us. So let's go ahead and just rerun our application here, and we'll be able to see that this function self row and index path, we see that it's actually being called 5 different times here, and it starts at 0, it goes to 1, 2, 3, and 4. So we know that if we want to differentiate between each one of these rows, this function is going to be called 5 different times, and we can use if statements, we can do different types of control flow in order to determine how each row should look different, or maybe have different text. Now, it's not enough that we have our cell displaying. We want to dynamically add some information to our cell so that our cell is a little bit cooler than it is right now. We're going to go to our main.storyboard file here, and we're going to go ahead and we're going to add some labels to our cell here. So we can add 3 different labels. 1, 2, 3 labels here. And let's change the size of the font for our bottom 2 labels here. So I'm going to make these both 12. And let's also go ahead and enlarge these labels. Give ourselves some more space here. Make this label a bit larger. We'll use our blue guiding lines here. I'm also going to align this text to be center. And I'm also going to update the names on these labels. Now, our user shouldn't see these names, right? These aren't going to be very descriptive. We're going to say subtask, and then we can say over here, we'll call this date. The reason I'm naming these is purely for myself. And by myself, I mean the developer making this application. When they want to go back and look at their storyboard, it'll be very obvious to them what each label does. So if a label should be displaying task information, it'll be very obvious when they take a look here and they see this label named task. We're going to actually be displaying task information, right? So we won't see this word task. But once again, it's a lot easier if you name these things properly in your storyboard when you go back and look at it. So let's hook these elements up. We're not going to hook them up to the viewcontroller.swift file, which is what we've done in the past. We're going to hook this up to the task cell. And the reason we're going to do this is we have a special class here that we created named task cell, and it's managing this UI view instance here. So we're going to be able to hook it up directly to the task cell.swift file. So let's hold down the Alt key and press on task cell, and this will bring up our assistant editor. I'm going to quickly just close the project navigator using this button over here to give ourselves a little bit of space here. And I'm also going to actually just adjust this so I can give myself a little bit more room to work with. So the first thing we want to do is we want to hook up our task label so we can have it highlighted, and we can confirm that in our scene outline. And we're going to be able to control drag into our task cell .swift file. So I can release here, and we're going to make this an outlet, and the name is going to be task label. It's going to be of type UI label, and the storage type will be weak, and we can connect that up. And this is the same way we've generated IB outlets in the past. We have the IB outlet keyword. It's going to be a weak storage. It's going to be a variable. The name is going to be task label, and it's going to be of type UI label. And we're going to have our exclamation point here to unwrap it. Let's also hook up our second label here. This we're going to call date label. And we can connect this up. And finally, we can hook up our last one here. This is going to be our description label. So each one of these labels is now hooked up to our task cell. So we're going to be able to access these properties in our view controller file by saying, task cell, or we're actually calling it the variable name cell dot task label, or cell dot date label, or cell dot description label, right? And then we're going to be able to play with these labels the way we played with all of our labels in the past. So let's actually practice this. We're going to open back up our navigator here. And we're going to go back to single view. We're going to go to the view controller.swift file. And now we're going to be able to update the text information on each one of our labels here by saying things like cell.tasklabel.text is going to be equal to study French. And then we could say something like cell.descriptionLabel.text is going to be equal to verbs in past and present. And then we can say cell.datelabel.text is going to be equal to 01/10/2014. Now let's try rerunning our application. And we see that this now appears in all 5 of my cells. And that's because this function, self_row_index_path, is being called 5 times. Each time it's called, it's going to find the cell. It's going to be reusing it. From our storyboard here, we've added some labels to the prototype cell in our storyboard, and we hook those up to our task cell.swift file, and we're now able to access these properties by saying cell dot and the names of the IB outlets we created, so task label, description label, and date label. And we are just hard coding these for now. Later on, we'll make these dynamic, and we can see that this information is now being displayed in each one of the cells in our table view. Right now we're displaying information on our cells, but it's pretty boring. So what we're going to do is we're going to do a little bit of refactoring, and we're going to add an array that's going to store some information. We're going to specifically be storing dictionaries, and these dictionaries are going to be key value pairs. We're going to see what that looks like in just a couple of minutes. And each one of these key value pairs is going to represent a label that we're going to update. So we're going to have one for our task, our subtask, and our date. And we're going to generate these dictionaries. We're going to generate specifically 3 different dictionaries to represent 3 different tasks. And we're going to encapsulate the information for each task, which will represent a row in our table view. So we're going to be able to display 3 different task information bits inside of 3 different rows. If that sounds a little confusing, let's see how this works. We're going to go ahead and jump right into this. We're going to add a property. And this property we're going to say is going to be a variable. Its name is going to be task array. And then we'll specify that we're going to be storing dictionaries inside of this array. And then each one of these dictionaries is going to have a key value pair that's going to be a string and a string for the key and the value. And then we're going to set this equal to an empty array. So what does that mean? Well, let's try setting up our first dictionary here. We're going to say let task1, and we're going to specify that this is going to be a dictionary, and it's going to have, once again, a key that's going to be a string and a value that's going to be a string. And we're going to set this equal to task : colon, and we're going to say study French, comma, subtask, colon, verbs, and finally we'll do date, colon, and we'll say 01/14/2014. So what's going on here? Well, we're creating a constant, and this constant's name is task1, and we're specifying that it is going to be a dictionary, and it's going to have inside of the dictionary key value pairs that are strings. So how does this equal a dictionary? Well, we're going to use our literal syntax here, and we're just going to use brackets, and this is how we're going to create our dictionary. This kind of looks like an array, but it's different in that we're setting key value pairs here. Now, that's what this colon is for. It separates our key, which is going to be task, and our value, which is going to be study French. Notice that these are both strings. So in our second key value pair, right, we're separating this with commas. We have subtask, which is our key, and our value is going to be verbs. In our third case, it's going to be, our key is going to be date, and our value is going to be 01/14/2014. So we could do a quick print line statement here just to see how task one works. Let's type print line. And in order to get back a value, we just have to pass in a key on our dictionary. How do we do that? Well, we can say task one, and we're going to say, okay, give me back the value for the key task. And, while we're at it, let's try another one of these. We can say task one, and then let's ask for the date. All right, we could obviously do the same thing for our subtask. We'll just limit this to 2. And when we run our project here, we see optional study French. So we're able to get the value study French back. And then if we use the key date, we get the value of 01/14/2014. So we're able to get back the values using the keys from our dictionary. Now, how do key value pairs make sense? Well, if we use the same keys over and over again, we're going to be able to access different values based upon the dictionary we're asking for. We'll see how that works in just a little bit. Let's set up some additional dictionaries here. So we're going to say let task2, and once again, we're going to specify this is a dictionary and it has key value pairs that are both strings. And let's set these equal to task. Notice we're using the same key here. But we're going to use a different value. So we'll say eat dinner. And then our second one will be subtask, right? We're going to use the same key. And this time we'll say burgers. And then finally we'll say date. And let's just use the same date. 01/14/2014. We're setting up our optimal day here. Now, notice these are both strings. If we made this an integer, for example, this dictionary would no longer be valid. We would have to change all of the values to be actually numbers here. So we'd have to do 2, 3, 4. Any integers would work here. But right now we're specifying it's going to be strings, so both the key and the value need to be strings. So we can say let task3, and we'll say dictionary, string, comma, string. And let's set this equal to the same key. So we're going to do task, and it's going to be gym, comma, subtask, and we'll do colon leg day, my least favorite day of the week. And then we're going to do date, comma, 01/14/2014. So we now have 3 dictionaries, and we know we have an array up here. This was our task array, and we set up this funky syntax here. Oh, I made a mistake here. Sorry, this should be a colon between date and the date here. So sorry, back to the task array. We have task array, and we're saying this task array has dictionaries inside of it, and each dictionary must have a string and a string. So that looks like all of the dictionaries we've set up here. So we can add all 3 of these dictionaries that we've named task 1, task 2, and task 3 to our task array. So we can say task array is equal to task 1, comma, task 2, comma, task 3. So now our task array stores 3 dictionaries. Well, let's first update the number of rows in our section to be equal to the number of elements inside of our task array. So we can say this is equal to task array.count. If you'd like to use the self keyword here, you're totally fine to do that because this is a property. We don't need to use that though. And we're also going to go ahead and we're going to update our self for row at index path. Now that we know that we're going to have 3 rows, right? We want to display all 3 of our tasks. Our task 1 is going to be in our first row, our task 2 is going to be in our second row, and so on and so forth. So how can we do that? Well, the first thing we want to do is we want to access one of the dictionaries from our task array. Now, we know that this function, self row at index path, is now going to be called 3 times because we're saying the number of rows should be equal to the count of our array, and our array has 3 elements in it. So this function self row at index path will be called 3 times. And we first want to access our first element in our array. Well, we know that in order to get the first element in our array, we could say something let task dict. We're going to say this is going to be a dictionary is equal to task array, and we could do like 0, right? We could just hard code this, and that would give us our first element inside of our task array. But what happens when this function gets called again, self row at index path? Well, we're going to get back the same element from our task array over and over again. So that doesn't work. We want to make this dynamic. Each time we call this function self row at index path, or each time Apple calls this for us, we want to get back a different element from our task array. So instead of indexing into the 0 element or the first element in our task array, let's make this dynamic. So we're going to do index path dot row, and we know that this is going to change, right? It started at 0, went to 1, 2, 3. So each time it'll access a different element inside of our task array. So this is how we're going to get back all of the different elements inside of our task array. And we're going to set it equal to the constant named task dict. So we can now use task dict, which we know is a dictionary, to update each of the elements for our cell here. So we could say task dict, and we'll index into it first asking for the value for the key task. And we can say task dict, and we'll say subtask. And then finally, we can ask for the date. So we'll say task dict, and we'll say date. Now, notice here that because we set up the same key for each one of our dictionaries here, this is going to work great because we're going to be able to reuse these keys, but get back different values each time we access a different dictionary inside of our task array. So that's going to work great. Now, let's go ahead and run our application, see if this works. And we now see that all 3 of our elements appear properly inside of our table view. Now, if for some reason you wanted to, make changes to your array in another function, we have this really cool function that we can call. So we'll just do this in view did load. It's properly showing, so we technically don't need to do a refresh here. But I can show you how we can do one. So we're going to simply say table view, and I really like to use the self keyword when I'm accessing my IB outlets. It's just kind of a habit I have. So I'm going to say self.tableview, and we can call this function reload data. And what this will do is it'll say, okay, refresh the information in my table view. So it's going to recall both of these functions, number of rows in section and self row at index path. And if the task array had changed, it would go ahead and refresh the information inside of there for me. So this is a really cool function. I'm just introducing it now. We're going to be using it quite a bit in the future. And so I just want to explain how we can use it. And calling it here, we're going to refresh our table view twice, so it's not really optimal. But in our future videos, we're actually going to do a bunch of refactoring anyway. So I wanted to show you that we can add this and what it really does. I want to explain what this function does. So hopefully you understand the idea that we're now using a dictionary to encapsulate some information about a task. We're storing that information into an array here, and then we're iterating through the array because we know the self row at index path function is being called multiple times. Now I know we did quite a bit, so I recommend, if you're a little bit confused, you go back and you rewatch the video once or twice. This is a really common design for iOS, using an array in order to populate information inside of a table view. So understanding what we're doing is pretty important. And using dictionaries is also pretty common. Dictionaries are a really common type of instance that you'll see in Swift. So right now we're using dictionaries in order to encapsulate the information for our tasks. And this is great. It gave us a chance to understand dictionaries. But let's try doing a little bit of refactoring in order to encapsulate our information with a struct. And this struct will allow us to encapsulate the information for our task. Specifically, when we had a task key, a subtask key, and a date key, we'll just make these all properties in our new struct. So you might say, okay, well, why did we bother doing this whole, task array with dictionaries first then? Why didn't we just jump right over to this? I know how to make structs. And one of the points is I want to show you how we can do some refactoring. We're going to do this quite a bit in our projects. It's going to be in the real world what you're going to be doing all the time. You're going to be adjusting things, optimizing things, deciding you want something a little bit more modular. So being comfortable with that is really important. So stick with us. We're going to go over this whole process together. We're going to go to File, New File, and we're going to choose iOS Source, Swift File. We're going to choose Next, and we're going to call this Task Model, and we can create this. And we see that we're immediately importing Foundation. So all we need to do here is we need to use the struct keyword. We need to give this a name, so we're going to call this Task Model. And then we're going to add 3 properties here. We're going to say var task. And we're going to say that this is going to be a string. And then we'll say var subtask, and this will also be a string. And finally, we'll say var date, and this will also be a string. Now, we're not going to set up our task model instances in this video, but what we will do is we'll go back to our view controller here, and we're going to update our task array here. So that instead of holding a dictionary, we want it to hold task model instances. So all we got to do is just change that code in there, and this is going to hold a task model. And we see that our code's going to break down here because our task array is now trying to hold dictionaries instead of task models. So in our next video, what we'll do is we'll do a bit of refactoring here to change all these tasks from being dictionaries to being task models. So now we're going to do some refactoring of our 3 task constants here. And we're going to change these from being dictionaries to task models. So let's go ahead. Actually, we can just add this code right above and then delete these dictionaries. We're going to say let task1 equal, and we can say task model. And we can initialize this with our task, our subtask, and our date here. So let's just hit the tab key and jump over to our task here. And we'll just use the same ones that we had before. So we're going to say study French, and the subtask will be verbs, and the date will be 01/14/2014. And hopefully you can see that that's a little bit easier than having to write these dictionaries, that we didn't have to rewrite all these keys and we were able to tab in and just make these properties of our task model instance. So we can go ahead and remove this first task here, and then we can do let task2, and we'll say task model. And once again, we're going to use the autocomplete here, and it'll be eat dinner, and the subtask will be burgers, and the date will be 01/14/2014. Now, for our third one, we'll actually do this inside of the task array. So I'm just going to go ahead and cut using Command X and Command V. We'll just paste this right above here. So we're adding task 1, task 2. Now task 3 is not valid. And when we create this array, we can actually create the task model right inside of this task array. Generally, I like to create these ahead of time. I think it just is a little bit easier for me to read rather than trying to see that I'm initializing an array and then also initializing a task model inside of it. But some people like to kind of chain this stuff all together. So I just want to show you that this is possible. So in here, we're going to do gym, and then we'll do leg day, and then we'll do a date. And we see that we're able to create this task model, or the third task model instance, right inside of our creation of our task array. So we can just go ahead and remove the third task here. And this will allow us to have a task array that we can now use to update our self-row at index path function. Let's go ahead and just remove this print line statement. We don't need that anymore. And we have an issue now. And the issue is that we're no longer accessing a dictionary from our task array. So saying task array index path.row is going to be equal to some sort of dictionary here is not valid anymore. So what we actually want to do is we want to say that the task, so we can say let task Or if we want to be, a little bit more explicit or kind of come up with a different constant name here, we could say something like let this task equal task array index path dot row. And that'll essentially say, okay, give me back this specific task for this row in my table view from my task array. So we're going to index once again into our task array using index path dot row. And with this task, we can now update our task label, our description label, and our date label. Now, we're no longer going to say task dict and then use some sort of key here. We can just say this task dot task, and then we could say this task dot subtask, and then we could say this task dot date. And you see, if I had left this as task, I would have said task dot task. And yes, that would have been technically allowed, but it would have been a little bit confusing. So by explicitly calling it like this task, you could call it like task model instance. There's a whole bunch of different, constant names you could use here. You're going to avoid having task.task, which doesn't really look too great in code. So let's try running our application here and make sure that our information is still populating. So our refactor was successful. We now see 3 cells, each with the information that we had previously seen, but we're now using our task model struct to encapsulate this information. In this video, we're going to go over adding an additional view controller to our storyboard here. So we're going to go to our main.storyboard file, and I'm just going to close this left-hand pane here to give myself a little bit of space to work with. We're going to open that up in just a minute. And what I'm going to do first is I'm going to add an additional view controller. So I'm just going to drag that into my project here. You can also hit the return key, and that'll also add it to your storyboard here. And we want to make this a task detail view controller. So we're going to be showing off our date. We're going to be showing off our task and our subtask. We're going to be adding those both to text fields. We're also going to be adding a date picker, and that will allow our user to change the date of a task and also be able to initially see their task, right, populated from the original view controller or the information in our table view. And then they're going to be able to edit it and update it if they want to. Well, first things first, we need a class to manage this view controller here. So how are we going to do that? Well, let's open back up our project navigator here. And I'm just going to do this right below my view controller.swift file. So I'm going to select this here, and this will place my file in the proper spot. You can also just drag this if it comes out in the wrong spot. So we're going to do iOS source Cocoa Touch class here. And we're going to make this a subclass of UI view controller. And let's call this task detail view controller. It's pretty explicit about what this view controller is doing. And we're going to make sure that we have the language is Swift here, not Objective-C. We are not going to check the option to create a zip file. We don't need a separate GUI interface in order to adjust or add a different UI elements to this specific task detail view controller. We're going to be adding this all into our storyboard. But the option is there if you wanted a separate interface to work with just the task detail view controller. And this is, again, subclass of UI view controller, the same way we've done for our view controller in the past here. Apple automatically made our view controller.swift file a subclass of UI view controller. If you're working in a very large project, you might want to change the view controller name, maybe main view controller or something like that, just to make it a little bit more explicit the way we're doing here with our task detail view controller. So we can go ahead and press next and press create. And we see this is automatically going to add our viewDidLoad function. We know that viewDidLoad is called when our task detail view controller first loads up. And what's really cool here is actually even have a comment for the prepare for segue function. We're actually not going to be using that in the task detail view controller, so we can actually just go ahead and delete that. But it is there. It's also nice to have the did receive memory warning. We shouldn't be getting any memory warnings inside of our application. If you do get them, you're either doing something really wrong or really, really right. You're doing some crazy cool processing that I don't know about. But for our purposes, you shouldn't be seeing them, and in our lectures, you won't be seeing memory warnings. So we have our task detail view controller. It's a subclass of UI view controller. We're automatically importing UIKit. Hopefully the rest of this looks pretty straightforward to you. Now with this new task detail view controller.swift file, we can go back to our storyboard, and I'm going to once again just close out my project navigator there using this button. And let's go ahead and update. We're going to make sure we have the second view controller and not the first view controller, right? They both say view controller, which can be a little bit confusing here. Make sure that we have the second one selected here. And it should be outlined in blue. And I'm going to go to my identity inspector, which is the third one here. And we're going to change the class to task detail view controller. So now we see that this task detail view controller scene populates here. It's really obvious the difference between these two view controllers. Now we want to add some UI elements to this. So we're going to add some text fields first. We're going to add 2 text fields. And we're also going to add a date picker. We'll do some resizing in just a second, but we want to get all our UI elements in here. And let's resize our date picker. I'm just going to go to the size inspector so I can be sure of the width here. We're just going to make our width 320. I'm going to kind of shift these to the top here too. In case you use a different device, I just want to make sure that, nothing's getting cut off the bottom. And let's just change the width for our first text field here to be not 380, 280. And notice I have this nice blue guiding line here. It's going to give me a 10-point border here to the top and to the left. And let's do the same thing here. I'm going to give a little bit more space for this one. And let's set this to be like 280. So this should all fit into our iPhone 5, 5S, right? The 320 width screen, this will fit in perfectly. Now let's add some default text to our first text field. I'm going to go to my attributes inspector here. And let's just call this task. And like our labels in our prototype cell that we had, we're going to be immediately updating this when we show off our task detail view controller scene. So the user should never see this word task. Let's also add subtask, and we can drop that right here. Now let's hook up our first view controller to our task detail view controller. And I think the easiest way to do this is from our view controller scene here. If you can't see it again, just use that button at the bottom here to open and close this, right? Open. And we're going to make sure we have our view controller scene here. I'm going to hold down the control key and I'm going to drag down to task detail view controller. And I'm going to select show from the manual segue here. And what this will do is it'll automatically add my nav bar here. So my nav bar shows up. And this is great. If I don't choose show, right, if I select my segue here, you can just click on that, and I change this to present modally, we'd see that I don't get my nav bar, right? So it's important that we select the show segue so that we get the nav bar and we get the back button for free. Now we see that this right now is hiding my text field. So let's just shift down my task text field so I have a little bit of space here so I can see it's not being eclipsed by the nav bar anymore. And I'm just going to shift my date picker up a little bit, make sure that we can see that, and my subtask up just a little bit here as well. The final thing we want to do in this video is we want to give our segue a name. So we're going to change the identifier here to show task detail. And this way we'll be able to access our segue in code. And when we say, okay, perform the segue named show task detail, we'll be able to transition from our view controller to our task detail view controller. It's time to make the transition between selecting a cell and the task detail view controller occur. The first thing we're going to do is we're going to add a print line statement in the function did select row at index path so we can actually see which cell we're tapping on. We actually want to see that information print out. And we want to see that this function gets called each time we tap a cell. So we're going to do print line, and we can do index path dot row. The second thing we're going to do is we actually want to figure out how to make our segue occur to show the task detail view controller. So in order to do that, we can say perform segue with identifier, and we're going to do show task detail. And the sender, we can just send self for now. Sender here would allow us to pass some information when we actually set up a prepare for segue function. So if I quickly just implement this up here, we'll actually fill out all the details. But if I start typing prepare for segue, we see that it gets a parameter of sender here. And this sender is the argument we pass in down here. Since we're not using this, we can just pass the instance of ourself and essentially, we would have access to the current view controller. We already have access to it, so we don't need that parameter. So let's go ahead and run our application here, and let's actually see the different rows being tapped here. So if I tap on the first row, we should see 0 print out, right, which is the first row in my table view. And if I go back to my simulator here, let's press the back button. Let's press on gym, and this should be my third row, which is index 2. So we see that the index path.row reflects the row I'm currently selecting in my table view. And then we're able to make the segue occur, right, which is the transition between my current view controller and the test detail view controller, by saying perform segue with identifier, show test detail. And this basically goes and looks at my storyboard, and it says, okay, does the view controller have a segue named show test detail? Yes, we do. Okay, so when this segue occurs, where should we go? Well, we're going to go over to the test detail view controller, and it's a show segue, which means that I need to give it a navbar when it shows up on the screen. So the reason we have this identifier right here is we could have multiple segues from a single view controller, and we're going to add an additional view controller in the future so that we can differentiate between the segues. We add an identifier here, and we're able to access this from the storyboard by passing in the string as a parameter to the function perform segue with identifier. So now we want to set up the prepare for segue function. So we're actually going to be able to pass the task model instance that we're going to be selecting in our table view over to the task detail view controller so we can display it eventually. Well, before we get started with that, we're going to go over to our task detail view controller. We're going to add a property, and this property is going to be named detail task model, and we're going to say that this is going to be a task model instance. So we're specifying that here. We're adding the exclamation point because we're actually going to be passing a task model instance. We're going to make sure of that ahead of time. So we don't need an optional here. We're going to go ahead and actually just pass the actual value. So with this property, we're going to be able to access the upcoming instance of task detail view controller. When we press on our cell, we know that we're going to go to the task detail view controller. So we can actually gain access to the upcoming task detail view controller inside of the view controller. And the way we do that is we access that inside of our prepare for segue function. Now, prepare for segue is called right before the new view controller is presented on the screen. So we have access to our segue here, our UI storyboard segue, and the segue has a property called destination view controller. So we can figure out we're going to the task detail view controller. So how are we going to do this? Well, the first thing we're going to do is we're going to run a check here to confirm that we are in fact going to the task detail view controller. How can we do that? Well, we're going to say if segue.identifier equals show task detail, and we'll add some curly braces here. And what we're going to do here is we're going to confirm that the segue's identifier is in fact show task detail, which means that we'll be presenting the task detail view controller on the screen. Right? So if we have multiple segues in our view controller, each segue is going to call the prepare for segue function. Right? So this can be called from a variety of different segues. So we're going to add some sort of control flow here to ensure that we're going to the proper view controller here. So the next thing we want to do is we need to gain access to the upcoming task detail view controller. We need to gain access to the instance that we're going to be presenting on the screen. So how can we do that? Well, we're going to create a constant. We'll say let detail VC, VC is view controller for short, and we're going to say task detail view controller is equal to segue.destination view controller as task detail view controller. And what are we doing here? Well, we're saying that our segue has a property, and that's named destination view controller. Now, the destination view controller can change based upon which view controller we're transitioning to. And right now, we've checked to make sure that we're going to the task detail view controller. So we can use this as keyword. We've seen this in the past. We're going to be able to specify that this is a task detail view controller instance. Now, why do we have to do this? Well, the segue, specifically the property destination view controller, doesn't know that this is a task detail view controller instance. We know that because we've written our checking logic here. So now we can create this constant named detail VC. And the next thing we need to do is we need to gain access to which row was selected in our table view. Now, we could have just passed this as the sender here, but I'm going to show you another cool function, and we're going to say let index path equal self.tableview.index path for selected row. And what this is going to do is it's going to tell us which index path, remember index path is both a row and a section, was currently selected in our table view. So with this, we're going to be able to gain access to an instance of ns_index_path. And with that, we're going to be able to say, okay, which task is currently selected? So we can get that from our task array. So we're going to say let this task equals task array. We're going to say index path. Now we actually have to unwrap this because this is going to be an optional. Index path for selected row returns an optional here. So we're going to say index path !row. And this will give us the task from our task array. We're getting this the same way we did as we did in self-row at index path, except that our index path, in this case, because we're using the index path for selected row function, returns an optional, we have to unwrap it. So we use the exclamation point here. And then we can say detail vc.detail task model is equal to this task. Now I mentioned we could have passed this argument in as sender, right? We can pass anything we want in as sender. So we could have passed in our index path to the sender here, and then we would have just been able to use sender, right, is equal to index path. And then we would have just been able to use the index path without the exclamation point, right? So this is another way we could have done this, but we're gonna stick with our cool way that we were able to do this with the index path for selected row. I just want to quickly show you that because that's a parameter you can pass in. Maybe you guys have seen it done that way before. Always cool to see a different way to do things. Now we're not going to update our test detail view controller quite yet, but what we will do is we'll go into view did load, and our view did load in the test detail view controller is going to work very similar to view did load from view controller. This is going to be called when the test detail view controller loads up for the first time. So let's go ahead and we're going to just add a print line statement here. And let's go ahead and just print out the self.detail task model. We actually don't need the self keyword here, but we're accessing a property. We can use the self keyword. And then we're going to do .task. We'll just print out the task for now. You could also print out the subtask or the date if you wanted to. That's fine as well. So let's go ahead and run our application here. And let's press study French, and we should now see study French prints out to our console. So just going over this one more time real quick, we set up the prepare for segue function, and prepare for segue is called before our segue occurs. So this is a really good time that we can get access to the upcoming destination view controller. And then we were able to set this property detail task model that we added to our task detail view controller to pass some sort of information. Now you might say, okay, well, if we're going to have these text fields, why don't we just say detail vc dot, whatever the name of our text fields are, and just update these UI elements, directly in the prepare for segue function. And the reason is that's not technically allowed. So the UI elements in prepare for segue have not yet been created, right? They haven't been initialized yet. So if you try to set them here, it won't work. That's why we have this design pattern of passing some sort of information. In this case, we're passing an encapsulated struct, right, that has a bunch of information bundled. And we're going to pass that over to our test detail view controller. We now can see that inside of our view did load function. And then we're going to be able to use this property to update our UI elements inside of view did load. Now we actually want to show off our information in our task detail view controller, but right now we don't have any IB outlets. So let's go ahead and fix that. Let's open up our storyboard here. So main.storyboard file, and let's hold down the Alt key and press on test detail view controller. Now we see this little scrunch. I'm going to go ahead and just close out both of these side menus here so we can have a little bit more room to work with. And we'll scroll up to the top here. Actually, I clicked on the wrong view controller. I want the task detail view controller, not my regular view controller. There we go. So let's go ahead and we're first going to hook up our task text field. So let's hold down the control key and drag into the task detail view controller. Let's make this an outlet. The type will be UI text field and the storage type will be weak. So we can call this task text field. And let's connect this up. And let's do our second text field next. And we'll call this subtask text field. And then finally, I want to hook up my date picker. So we're going to say due date picker. And we now have all three UI elements hooked up. This is going to allow us to access each one of these UI elements. And we see that we now have this new type UI date picker. But this is going to work very similar to a lot of other UI elements we've hooked up. It's going to have some properties. We're going to be able to access it with due date picker or self.dueDatePicker. But one of the parameters we're going to need to update, or one of the properties we're going to need to update, is going to be the date property. And we don't know how to create nstate instances yet. So we're going to have to do that in the future. For now, let's go back to single view and we'll open up back my menus here. And let's go to our task detail view controller. And I can just remove this print line statement here. And let's update both of my text fields. We're not going to update the due date picker because once again, we don't know how to create nstate instances yet. So let's say self.taskTextField.text is equal to detail taskModel.task, right? And that's all we're doing here is we're updating the text property of our task text field. We're using the self keyword. I like to access properties often with self. I'm going to kind of do this interchangeably throughout the course. So remember that they're synonymous, but we can use that self keyword, and it's really useful to use that self keyword when we have a local variable or a parameter that will have a name conflict. So the other thing we want to do is we're going to do self.subtaskTextField.text. We're going to say this is equal to detail task model.subtask. And let's go ahead and run our application now and make sure that my text fields are updating properly. Let's choose eat dinner this time. And we see eat dinner and burgers is now pre-populating inside of my text field. So the update is in fact working. So we know that we need to update our UI date picker and that it has a property named date, which is an nstate instance. Well, we're going to go ahead and just update our task model then because we want to add an actual date here. So we're going to change this string to be an nsdate. This is going to break a few things inside of our application, specifically in our view controller. But right now, we don't really have an easy way to create an nsdate. And the reason for this is Apple hasn't included one in Swift as of this current point in time. Maybe it'll add it to the library in the future. But for right now, the easiest way to do this for us is going to be to create our own class in order to return an nstate instance. So we're going to get to learn about what goes into making an nstate instance. So let's do that. We're going to create another class here. So we're going to go to File, New File. And we can just choose Swift File here. We don't need to subclass this to anything. So we can just have an empty file here. And we're going to write this in as date. This is going to be the name, and we're going to choose our target. It's going to be taskit. So this will create a date file for us. And we're going to choose to call this date. So we're going to say class date. And we're going to add some class functions here. We've done this in the past. And basically what this means is when we call this function, we're just going to call this on the class date. So we're going to say class func. And we're going to say from, and we're going to do $year. And we're going to specify that this is an int. We'll talk about what this means in just a sec. And then we're going to do month, :int. And then we're going to do day, :int. And we'll say this is going to return an nstate instance. And for now, while we're explaining this, we're just going to return nstate like this. So let's go over what our function declaration is. We're saying this is a class function, so we use the class keyword, and its name is from. Now we add this pound sign, and what this pound sign does is when we actually call this function, we'll see this first parameter populate with a year, and we'll be able to enter an integer in here. If we don't add the pound sign, all we would do would be to enter a number, and it's nice to have this identifier for year because it's not really obvious to us when we're calling this later on just based on this function name of from. We're also going to pass in a month and a day, and these are both going to be integers. And with these three pieces of information, we're going to be able to return an NSState instance. So we're also going to need to create some additional instances inside of this class function to actually create an NSState instance. The first one we need to create is an NSState components instance. So how are we going to do that? Well, we're going to say var components. And we're going to set this equal to NSState components, and we'll just initialize it. And from a components instance, we can now set a year, a month, and a day. These are all properties. So we're going to be able to say components.year is equal to year. And this is just our parameter here. And we can say components.month is equal to month. And then we're going to say components.day is equal to day. So we're just updating the property of our components with our parameters here. I know that they're named the same, so that might be a little confusing, but our parameters are the ones in black here, and our properties here are the ones in purple. So with an NSState components instance, we're going to be able to create our NSState instance in just a second. We first need to create an instance of NSCalendar. So how do we do that? Well, we're going to say var Gregorian calendar is equal to NSCalendar. And we're going to pass in an identifier here. This is a custom initializer. So we're going to pass in NS Gregorian calendar. And this will return an NSCalendar instance. And from an NSCalendar instance, we can create an NSState instance very easily. So all we have to do is var date is equal to Gregorian calendar dot date from components, and we'll pass in our components parameter. So what's going on here? Well, we need to actually specify the calendar type. We can actually hold down the Alt key and press on NSCalendar in case you're curious as to what exactly this is. It says the calendar encapsulates information about systems of reckoning time. So what we're doing here is we create an NSState components instance. We pass in the year, the month, and the day, and then we create an NSCalendar instance which is able to encapsulate all of this information properly in order to transform this into an NSState instance. So we say Gregorian calendar dot date from components, and we pass in our components, which is the encapsulation of the year, month, and day. And we're able to get back an NSState instance, right? So if we hold down the Alt key and we press on this function, we see that this function returns an NSState instance. Now we also see that this is an optional, so we're going to want to unwrap this before we return this. So we're going to say date exclamation point. And now our function returns an NSState instance. So we're going to be able to update our due date picker with this NSState instance, and all we're going to have to do is pass in a year, a month, and a day. So now we want to update our view controller to use our new date class so we can update our task model with actual NSState instances. So rather than initializing these inside of the parameter here, we're going to just go ahead and create 3 date instances ahead of time. So let's say let date1 equal date. We're going to use our class function here. And now we can pass in 2014 0520. And this will be our first date constant, date1. Let's create a second date, so we can say let date2 equal date. We're going to use our class function again. We'll pass in 2014 033. And finally, let's say let date3 equal, I'll say date.from. We'll do 2014 12, and we do 13. So now we can update our task model instances with the actual date. So we can say that this is going to be the date here, and this will be date 2. So just copying and pasting these in, Command C, Command V, in case you're not familiar with the short hand for copying and pasting. And finally, we want to update our date here as well for our task array when we're creating the task model inside. Now, we could have just, copy and pasted this whole thing in and just done this way as well. That's completely legal. But I think that this code looks pretty messy. So I like to just create my constants ahead of time. When I'm doing this, it's just a little bit easier to keep everything in line for myself. So now we have a bug in our project, and that's right now we're trying to update our date labels text property with this task.date. And this doesn't work because we need to pass a string in here. And right now our date property on this task is an nstate instance. So we need to figure out a good way to convert an nstate instance to a string. How can we do that? Well, we're going to add an additional function into our date class here. And our function is going to take in an nstate instance and it's going to return a string. So let's say class func, and we're going to say toString, and we're going to use this pound sign again. Remember, this allows us to see the parameter when we call this function. And we're going to say nstate, and this is going to return a string. So right now we need to return a string. We can just return an empty string so we don't get any errors. And this class function is just going to be named toString. It's going to take our nstate instance here, and remember the pound sign, so we'll actually see date appear when we call this function. If we don't have that, we won't see date appear. We would just be expected to know we need to pass in an nstate instance. And then we're going to return a string instance, and I like to always just make sure I have no errors when possible. So I always just return like a default instance until I'm ready to return the actual instance. So we're going to first create what's called an nstate formatter. And an nstate formatter, it has a property named date format where we're going to be able to specify what type of format we want back. We're going to be using year, month, and day. So we're going to see how to do that in just a second. The first thing is we need to create our date formatter. So we're going to say let date string formatter equal nstate formatter. And we'll just initialize it. And then we're going to say date string formatter dot date format, and we're going to set this equal to year mm-dd, and this is going to be year-month-day. And there's different types of date formatters you can do. You can add time if you want. You can kind of switch the stuff around. You could add forward slashes. I mean, there's a whole bunch of different things you can do. We're just going to use this basic date formatter. But if you're interested, it's not too hard to do a little bit of research, and you should be able to figure out other date formats really quickly. Now that you know that this date formatter instance exists and kind of what it can do. So in order to finally convert our date to a string here, we're going to say let date string equal date formatter, date string formatter, dot string from date. And this is a function we can call that accepts one parameter, and that's a date. So we're going to get that as our parameter we're going to pass in here. And from this, it will return a string. So we now have a string. Date string is now a string, and it's going to be in the format of year, month, and day. So we can now go back to our view controller, and we can find our line of code that's storing this error here. And we're going to be able to update this line of code to say date dot toString, and we can pass in our date. Well, where are we going to get our date from? Date is a property on this task. So we can say this task.date. And now when we run our application, we should now see the dates appearing inside of our cells. So we now see we have 3 different dates, and that ties out to what we added in our viewDidLoad function. And this is now coming out in the format of year, month, and day. We notice that they're separated by dashes. So that ties out to our nstate formatters format here. So once again, all we did was we created an nstate formatter instance. We set up what its date property should be, or date format property, and we just specified it should be year, month, and day. And then we converted to a string using the function string from date, and we just passed in an nstate instance here as a parameter. We got that from our parameter when we call the function. We get back a string and we return that. So when we actually call this in the viewController.swift file, in the self-heroic index path function, all we did was date and then toString. We have to pass in an nState instance. So we can get an nState instance from the thisTask instance, right? And remember that thisTask is a type of task model. And if we just quickly look at our task model, we see that we have a property date. So that's kind of how that all ties together. It's time to update one of the really cool features that we added to this application, and that's our due date picker. So we're going to go to viewDidLoad inside of the task detail viewController.swift file. And we're simply going to put in self.dueDatePicker.date is equal to detail task model.date. And we can go ahead and run our application here. And we should now see when we click on here, it's now going to the date we specified. So this is May 20th. Let's try eat dinner. This is March 3rd. So we're now actually able to update our due date picker to the dates we're setting for our tasks. And hopefully that wasn't too difficult. We only had one line of code in here. Not all our videos will be so easy. But we can see that updating this brand new kind of scary due date picker UI view instance is not so difficult, right? All we had to do was figure out it actually is kind of a different property. It doesn't have a text property, it's a date property. And we just had to figure out how to create an nState instance to update it. So in this video, we're going to be making some updates to our task detail view controller, and we're also going to be adding an additional view controller. So while we have our project navigator open here, let's just go ahead and select task detail view controller. I'm going to go to File, New File. And we're going to choose iOS source Cocoa Touch class because we're going to be subclassing UI view controller. And let's call this add task view controller. We're going to make sure we choose the language as Swift. We don't need a zip file. And we can go to press next and press create. And we'll use this new file in just a minute. For now, we know that we are going to get our boilerplate code generated here. And this is going to be a class called addTaskViewController. It's going to be a subclass of UI ViewController. And it's automatically going to have two functions, viewDidLoad and didReceiveMemoryWarning. We've done this before, or seen this before when we created our task detail ViewController. Now let's go back to the storyboard. And we're going to go ahead and just close my right and left panel here for just a sec. We're going to be updating our nav bar here. And if we open up our right bar here and we go to our object library, we're going to be adding bar button items. So we can type this in. And what these are buttons that can go either in a toolbar at the bottom or it can go in our nav bar at the top. So we're going to add two bar button items. I'm going to be able to just drag this in. Now, if for some reason you can't add it, it's just not allowing you to add it there. There is a little bit of a bug in Xcode I found myself. And the way I fixed this bug is I went to the segue and I changed this to push in the deprecated segues. And then I switched this back to show, and then it let me add it. So it was kind of a weird bug. I'm not sure, maybe Xcode didn't update properly here. Sometimes when you're switching between segues, maybe the nav bar got corrupted. Whatever the case is, making that change was able to fix it for me. And I was now then able to add some bar button items. We're going to add two. We don't want to leave the titles of these buttons to be item. That's kind of a silly title. So let's call this cancel, and we'll call this done. And while we're here, let's also go ahead and update the title here. If we just kind of double click in the middle, or we can select our navigation item, we can change the title of this view controller, and we're going to type in detail. Well, while we're changing titles, let's go ahead and update the task view controller here, or our main view controller. And we can just double click in the middle again. We can call this tasks, which is a nice representation of what we're going to be seeing in the table view here. And finally, we're going to add one additional view controller. So let's go ahead and search for view controller in our object library. We drag one in. And this is going to be our add task view controller. It's the class we just created in our folder navigator over there. And let's change the class here. So let's make sure we have our view controller selected here. And you're going to want to make sure you have the right view controller selected, right? Because we also have another view controller that could be confusing, right? These both say view controller. Although this says task scene now that we've changed the title, which is a nice identifier for us. And we're going to make sure we have the identity inspector selected. We're going to see this blue outline because we have this view controller selected here. And we're going to say add task view controller, and that will update the class of this view controller. We are also going to want to figure out a way to transition to this view controller before we start setting up UI elements on it. So let's go over to our tasks view controller here, and let's search for our bar button item. We can drag this into the upper right hand corner here. And instead of having a title this time, let's go to our attributes inspector. Let's change the identifier to add. And this will just change this to a plus here. It's a pretty cool icon. We notice that the title goes away when we change the identifier to add. And that should be pretty obvious to the user that, when we press this, that some sort of addition or adding of a task should occur. So let's create a segue from our main view controller to our add task view controller. Well, we're going to go ahead and select our view controller here, and I'm just going to control drag down to the add task view controller scene here. And we're going to release, and we're going to choose this time present modally. And what this will allow us to do is it'll allow us to create a segue that does not have a nav bar. We see that in our previous case, when we did a show segue, we got this nav bar. Presenting modally, we don't have a nav bar. And there are going to be cases when you don't want a nav bar to show up. So what we'll do instead is we'll add buttons ourselves. We don't want bar button items. We just want regular buttons. So we can add one button here. I'm going to do Command C and then Command V, and that'll allow me to copy my button here. And we'll say this is going to be cancel. And this is going to be add task. And then we're going to add two text fields. So let's type in text field here. And we can, once again, Command C, Command V. That will allow us to quickly copy it. We also need a due date picker. So let's type in date picker and drag one of these date pickers. And we'll do resizing in just a second. I just want to get all my UI elements in here first. We're also going to add 3 labels. So 1, 2, and 3. And we're just going to use these as identifiers. So this is going to be date. And this will be subtask. And this will be task. And let's just space out our UI elements just a little bit more. Give ourselves some space here so it's not, everything's not quite so on top of each other here. And the final thing we want to do is we want to resize this. Again, we're going to use that 320 width because we're going to assume, we're going to be using the iPhone 5, 5S, maybe the iPhone 4, something like that. So let's change the width to 320. And we're also going to change the width of these text fields. We'll make this 280. Make sure we have this using our nice blue guiding lines here. That'll give us a 10-point border. Or I guess in this case, 20-point border, excuse me. And we kind of have everything lined up now. We can also kind of move our add task button over and get this stuff lined up nicely. So there's 2 things I really want to point out in this video as we get started here. And that's the changes to our UI here have had 2 unexpected consequences. The first one we'll see when we run our application here. And this will not be a bug everyone experiences, but right now when I select my cell, I get an error here. And it says terminating app due to uncalled exception here, and it's going to say has no segue with identifier show task detail. And that's through all the switching of my segue and my main storyboard here. My identifier got removed. So switching to the push, switching back to the show, removing it, adding it back. Whatever you do, sometimes this goes away. So I'm going to go ahead and just add back my identifier here. And that will fix this bug. Now, the second bug we're going to see here is when I run my application. When I select a cell, this now works. When I press the cancel button, nothing's happening. So in the past, we've automatically gotten a back button that was generated for us. However, by adding our own bar button item to the nav bar, we've now lost that functionality. We're actually overriding the back button with our own custom button. So the first thing we want to fix is the ability to go back to our main view controller. It doesn't do to be stuck on this page. So let's go and hook up our cancel button. We're going to hold down the Alt key and press on view controller, on task detail view controller, excuse me. I'm just going to quickly close these 2 panels just so I have a little bit of space to work with. And we're going to add an IB action at the bottom here for our cancel button. Let's just control drag in, and let's make this an action. And we can call this cancel button tapped. And let's change the type to UI bar button item, and we can connect this. Now remember, this is just the parameter that's being passed in for sender. We're not going to be using that, but it is there in case we want in the future. I'm going to go back to this single view here. I'm going to open up my panels again. And let's go into the task detail viewcontroller.swift file. So with this IB action, we need to figure out how to make the current view controller disappear from our screen. Now, because we're using a navigation controller to push or segue onto the new view controller, we're using a show segue. Push was the one from iOS 7. We actually have to use the navigation controller to remove the current view controller. How can we do that? Well, because we're in a navigation controller, we automatically get access to the navigation controller property. And the way we can access that is by saying self.navigationController. And this automatically exists because we're use that show segue, which was inside of our navigation controller stack. Remember, we embedded our first view controller inside of a navigation controller. And then by using a show segue, we're still in the navigation controller stack. We can say self.navigationController.pop view controller animated, and we'll say true. And what this is going to do is it's going to pop the current view controller off of the navigation controller stack, and then it'll display the view controller before that. So let's see if this works. So let's go ahead and rerun our application here. And let's click on a cell and we'll press cancel. And we'll see that now our main view controller is showing back up. Now, we're gonna have to do this a little bit differently for our add task view controller, and we're doing both these in the same video so you can see the contrast between the two ways we can dismiss a view controller. So let's go back to our storyboard here, and let's hold down the Alt key and press on add task view controller. I'm gonna close out these panels just for a second again. And let's locate our add task view controller. Now we're going to hook up our cancel button. I'm just going to go ahead and remove this commented out code here so we have a little bit of space to work with. And let's select the cancel button, and we're going to control drag into the add task view controller. And we're going to make this an action. And we can say cancel button tapped. And let's make the type UI button. The event will be touch up inside and the argument will be sender, the same way we've hooked up buttons in the past. And let's connect this up. I'll go back to single view, open up my panels again. And let's go to the add task view controller. Now, this time we are not inside of a navigation controller stack. So we don't have access to self.navigation controller. And why is that? Well, we used the modal transition here. So if we take a look at our storyboard, we can locate our add task view controller here. And if we select this, we're choosing present modally. So we notice there is no nav bar, so it wouldn't make sense to tell our navigation controller to remove the current view controller. So in add task view controller, cancel button tapped, we can instead say, okay, the current view controller can be responsible for removing itself. So we'll say self.dismiss view controller animated. And we'll say that we do want this to be, we're going to use lowercase. We do want there to be some sort of animation, but we don't need a completion block. And what is a completion block? Well, when this transition is done occurring, do we want some code to run? And we don't need any code to run, so we can just pass in nil for now. So let's try running our application here. And we're going to see that right now, we have no way to get to the add task view controller. So what we need to do here is we need to go back to our storyboard one more time, and we need to give our segue here from our main view controller to our add task view controller an identifier. So let's call this show task add, and this will be our identifier. And then what we'll do is we'll hook up our UI bar button item for our addition here. So let's hold down the Alt key and press on viewcontroller.swift. I'm going to close down these panels just one more time. And we're going to make one more IB action. So let's find an IB action, a good place to put that. Let's do that right after the prepare for segue function here. And we're going to make sure we have our add bar button item pressed here or selected. We can make sure it's selected in the scene outline. I'm just going to control drag into my view controller here. We're going to make this an action, and we're going to say add button tapped, and we'll make this type UI bar button item. And we can connect this up. And all we have to do in this line of code here, let's actually just go back to single view here. It's nice to write code in a single view. Let's just find our IB action inside of the view controller file. And we're going to say self dot performs a segue with identifier. And our identifier is going to be show task add. And the center we can just send ourselves for now. And let's just try rerunning our application, make sure this works now. So we're gonna click the plus, and that's gonna show up our add task view controller. And let's try pressing the cancel button. And we're now able to transition back to the main view controller. So the real thing to take from this video lecture is the idea of there's two different ways we can dismiss view controllers. If we're presenting something modally, we're gonna do dismiss view controller. And if we're doing it inside of a navigation stack, we're going to say self.navigationcontroller.pop view controller animated true. In order to get ready to properly add a task, we need to do some additional setup first. So we're going to start off on our storyboard here, and we're going to hook up our 3 UI elements to our add task view controller. Later on, we'll set up our button, but for now, we're just going to go ahead and close these panels. We're going to add 3 IB outlets, 2 for our text fields and 1 for our due date picker. So let's go ahead and add our task text field here. And we can say this is going to be task text field. And we're going to make sure this is an outlet. And we're also going to make sure this is text field and the storage type will be weak. We can connect that up. We're going to do subtask. This will be called subtask text field. And once again, UI text field, weak, and an outlet. And finally, let's hook up our due date picker. And we're going to make sure this is a UI date picker. The storage type will be weak, and it'll be an outlet as well. I'm just going to go ahead and remove these spaces between my outlets just to keep it a little bit cleaner, a little more concise. And the final thing we were going to do in this video, we're going to keep this video pretty short, is we're going to add a property to our add task view controller, and this is going to allow us to pass an instance or the instance of our view controller over to our add task view controller. We're going to be able to have access to it in our add task view controller, right? So we're going to do var main vc. We're going to say view controller exclamation point. So when we do the prepare for segue function, we're actually going to be able to pass the view controller to the add task view controller. So we'll be able to access all the properties of our view controller in our add task view controller. This is going to work out really well for us as we make changes to our array, which is going to hold all of our task model instances. We're going to set up the ability to add an additional task. We're going to basically be creating a new task model based on what the user enters in our add task view controller. Right now, we need to set up one additional item from our storyboard. I know we've been doing a lot of storyboard setup, so we're almost in the home stretch here. And we are going to hook up from our add task view controller the add task button as an IB action. So I've made sure that I have alt clicked on my add task view controller to bring this up in my assistant editor. And I'm also selecting the add task button in my add task view controller. And we're going to control drag. And I'm going to choose action, and we're going to make this type UI button, and the name is going to be add task button tapped, and we can connect this up. And this is going to give us a good bit of space where we're going to say, okay, the user has entered some information in, and we're going to be ready now to create a task for them. So let's go back to single view here. We can open up our panels again. I know it's a lot of opening and closing of panels, but I figure a lot of you are using laptops, so it's pretty cool to be able to open and close these panels and see how to do that pretty quickly. So the add task button tapped function here is going to allow us to recognize when the user presses, okay, I'm ready to add a new task. So let's type in var task is equal to task model. We're going to say task, And the first is going to be from our task text field. So we're going to say task text field dot text, and then next we're going to access our subtask. So we'll say subtask text field dot text, and finally we're going to get a date, and we're going to get that from our due date picker. We're going to say due date picker dot date. So this is a little bit different than what we've done in the past. We kind of did this in reverse, right? Rather than updating the due date picker, now we're getting the information or the date from the due date picker. And remember that the date property is an NSDate instance. And for our task model, we've specified that the date variable or property is going to be also an NSDate instance. So these two match up quite well. And we're able to create a new task model instance. And this task model instance is going to be dynamic based on whatever the user's entering into both the text fields and whatever date they're adding. Now, we need a way to add this task to the task array. Luckily, we have this property main VC, and main VC from our view controller has a property named task array. So we can say main VC dot task array, and we do dot append, and we can add our task to it, right? So that seems a little confusing, right? But if we just talk about it one more time, right? We're creating a new task in our add task view controller, and we're passing in all of our parameters here, setting that properly. And then what we're doing is we're saying, okay, we will be passing the view controller to the add task view controller. We're going to set that up in our next video in the prepare for segue function. So when we pass over the view controller to the add task view controller, the main view controller or view controller is a property named task array, and this is housing all of our task model instances. So we can access that from our main VC property. So we can say main VC.taskArray, and then since it's an array, we can use the append function to add an additional task to it. The final thing we're going to do here is we're going to say self.dismiss view controller. We'll say animated is true. Make sure you use lowercase. I just hit the escape key. It auto enters capital true there. I'm not sure why it does that. It's silly. And then we're going to do completion is going to be nil because we don't want anything to occur when the animation is done. Why are we doing this? Well, we're going to assume when the user presses the add button, they're done doing stuff on the screen and they want to go see their task presented in the main view controller. So we're going to figure out how to refresh as well. Maybe you remember that table view has a reload function that allows us to reload the data inside of the table view, but we'll get to that later. For now, you just want to understand the idea that we're accessing the property main VC and that main VC has access to the task array. Even though we haven't yet set this, because we haven't set up our prepare for segue function yet, we will after the end of our next video. So if you remember in our last video, I'll quickly show you, in the add task view controller, we accessed the main VC property, right? We said we were going to pass that from our view controller to the add task view controller. Well, we need to do that. We're going to go to our prepare for segue function, and we're going to add a little bit of additional control flow here. We're going to say else if segue.identifier is equal to show task add. We'll add some curly braces. And the first thing we're going to do here is we're going to get access to the add task view controller we're going to be presenting on the screen. So we actually, sorry, I forgot another equal sign there. We need a second equal sign. We're doing a comparison, not a setting of a value. So we need to get access to the add task view controller. So we're going to say let add task VC colon add task view controller is equal to segue dot destination view controller as add task view controller. And then we can say add task VC dot main VC is going to be equal to self. Okay, let's talk about this code. The first thing we're doing here is we're checking that the correct segue is occurring, right? And remember that we gave our segue this identifier show task add. And we can just quickly check that in our storyboard here. If we click on our segue, we see show task add. So that matches up perfectly. So we're confirming we're going from the main view controller over to the task add view controller, or add task view controller. The next thing we do is we're creating a constant here, and the constant, just like we did with the task detail view controller, gives us access to the add task view controller instance that will be presented on the screen. So we're able to say segue.destination view controller. Once again, our segue doesn't know what type of view controller we're going to be presenting, so we specify as add task view controller. And then what we're doing, this is the kind of the tricky part, we added a property in the add task view controller, and we said that it was going to be of type view controller. Well, we have a view controller here. How do we pass it the specific instance of view controller? Well, we pass it self. Self represents the implicit instance that we're currently in, right? The current class we're in. So we're able to say add task vc.mainVC is equal to self, because self represents the current view controller we're in and the current view controller instance that's currently being presented on the screen. So with this in hand, the add task view controller can now say, okay, well, I know what instance is currently being presented for the view controller, and I know that that instance has a task array property, right? Our view controller is a task array property, so I can now start adding things back to the view controller. Now, there's other design patterns we can use to do this as well, but this is one cool way that we're able to explore the idea of self, explore the idea of passing self around, and how we can make updates from a different view controller to our current view controller. So in this video, we're going to figure out how to add tasks and have them display. We're actually going to run our application right now and see that if we add additional tasks, let's try adding a task here. We can add task test and subtask text test. And we pick a date for this. We press add task. It'll now appear. But I want to be very explicit about how we're making this appear. I believe what's happening in iOS 8 is there was an update which automatically detects our array count here and makes changes. Specifically, it'll call self-forward index path if we update the array count. And that's why in view.did_load, we really didn't need to add this reload data either. But there will be times when you make changes to a model, or there are times when you make changes in another view controller and you want the table view to refresh its data. So I'm going to show you how we can do that consistently every time we present the view controller on the screen. So how do we do that? Well, we're going to implement a new function, and this function is automatically included in the view controller, although we don't always implement it, so we actually have to go ahead and add it ourselves. What is the name of this function? Well, this function is called view.did_appear, and this function is called every time this view controller is presented as the main view controller on the screen, when we can see this view controller. So what do I mean by that? Well, view.did_load is only called the first time we load this thing up, right? But when we're transitioning back from the add task view controller or the task detail view controller, this function view.did_appear will be called. So in order to set this up, the first thing we're going to do is we're going to say super.view.did_appear, and we're going to pass in animated. And we're going to get that as our parameter here. Now, this is just calling up to the super class's implementation of view.did_appear, same way we did for view.did_load here. And we're just using whatever the animation, the default animation parameter is here. And then we're going to say table view. We could also say self.table_view, that's fine. Dot reload data. And this is going to explicitly tell the table view that it should refresh the information inside of there. So as I said, right now there's a cool optimization that Apple's done for us where it's tracking the array count for us. But there are going to be many cases when you want to do certain functionality when the view appears. And we get a really cool chance here to use view.did_appear. And it is a meaningful reason to do this because there might be additional changes to the model that can't be tracked. We want to just be very careful that every time we make a change in another view controller and represent our table view on our main view controller, we want to say, okay, refresh all the information in my table view. And that's all reload data is doing for us. So if we run our application here, we're going to see it's going to run exactly the same way. We're going to be able to add a task, and we're going to say subtask 2, and we're just going to be able to add this task, and it will now appear inside of our main table view. So we now want to set up our task detail view controller. So let's go over to the task detail view controller.swift file to have access to the main view controller as well, right? We've seen the effect of having access to the main view controller in our add task view controller. Specifically, we are able to update the task array. And hopefully it'll make sense that we also want to be able to update the task array from our task detail view controller. We're going to be able to update our tasks. And the way we're storing our tasks is in the task array. So how can we do that? Well, we're going to add an additional property. We're going to say var main VC. We're going to say this is going to be a view controller instance. And then we can pass this. So let's go back to our view controller, and we're going to find the prepare for segue function. And we can update detail VC dot main VC, which is going to be our property here. We're going to set this equal to self. So this is exactly what we did with our add task view controller. We just created an additional property in the task detail view controller named main VC, and we're just going to pass an instance of the current view controller to the detail view controller when we perform our segue. Before we get started updating our task, when we pass it over, we're going to just quickly make an update to our done bar button item. So we're going to first connect this thing up. So let's go to our storyboard here, and we're going to hold down the Alt key and press on task detail view controller. And we're going to add an additional IB action. So let's find our done button. And we can control drag in. Remember, this is from our detail task view controller, or task detail view controller in our storyboard over to the task detail view controller.swift file. And since this is a button, we want to make this an action. And this name is going to be done bar button item pressed. We've done like done button tapped. I like to, sometimes be explicit here. Generally, it's always nice to be explicit. So we could go back and do a little bit of refactoring, but those names will work fine. And we're going to say this is going to be a type UI bar button item. So I'm just trying to show you a different naming convention you could potentially use if you want to be explicit that this isn't a bar button item that is being pressed instead of just a regular button. Maybe that's the way you want to write your code out here. Making this explicit about the type, again, isn't really required. We're not going to be using this parameter, but it's nice to put it in there just in case you need it in the future. So let's connect this thing up, and we'll go back to single view again. I'll open up my panels again. And let's go into the task detail view controller. And we're going to go ahead and add just one line of code here and try to keep this video a little simple. We're going to just pop the view controller off the stack. So we're going to say self.navigation controller, and we're going to say .pop view controller animated, and we will make this animated. So just like we did with the cancel button, when we're done, updating a task and we press the done button, we want to go back to the main view controller. So we're just going to set up that dismissal right now. We're finally ready to be able to update our tasks rather than just be able to see the default ones we created or add a few tasks. So we're going to do this in the done bar button item pressed function inside of the task detail view controller.swift file. And the first thing we're going to do is we're going to create a task instance, or task model instance. So we're going to say var task is equal to task model. And we're going to pass in for our task text field dot text. And for our subtask, we're going to pass in subtask text field dot text. And for our date, we're going to say due date picker dot date. And if you wanted to access these properties with the self keyword, that would be completely fine as well. We don't need to, so I'm going to keep it a little clean here. And then what we're going to do is we're going to update our task array in our main view controller. Remember, we added a property, main VC, so we can access our task array. And we're going to say main VC dot task array. We're going to say main VC dot table view dot index path for selected row. We're going to say dot row. And we're going to set this equal to task. And actually, so we need to do exclamation point here. Sorry about that. We need to unwrap this. This is an optional. And let's just remove this additional line here. Keep this lined up nicely. So what are we doing here? Well, we're going to say, okay, from the main view controller, give me my task array. And we're going to go ahead and we're going to index into this task array. And we're going to say, what index do we want to access? Well, we want to access the index that the user has currently selected. So we're going to be able to say table view dot index path for selected row dot row, which row did the user select? And that's the one we want to update, or we're going to replace the instance in our array at this specific index with this new task we created. Well, what new task did we just create? We just created this task up here. We said var task is equal to task model, and we use the task text field.text, the subtask text field.text, and the due date picker's date property that the user would have been able to update when they pressed on all these different elements inside of the task detail view controller. So let's see if this works. We can go ahead and run our application here. And we're going to just click on study French. And let's say, oh, actually, I want to study Spanish today instead. And let's just change the date. When we press done here, we're going to say study Spanish is going to show up here. And the date will also have updated. And that's because we are going to be able to update or replace the item in our task array with our brand new task. But we're using the information we initially passed over to populate our text fields and our date picker. So if we don't make any changes, right, when we press done, it'll just replace it with the task items that we currently sent in. So this idea of accessing this task array from our main view controller property is the same thing we did in our add task view controller. We're just going about this slightly differently. Instead of appending an additional task, we're updating a task or replacing an item inside of our task array. So we now want to sort our tasks by their date. Right now, they're just coming in, we're adding ones to the bottom. Let's figure out how to do that. We're actually going to get our first exposure to closures and actually writing our own closure here. We've seen one before when we added our animation to our views inside of the Lions and Tigers project. But now we're actually going to kind of see how they work. We're going to start seeing like a beginning version of a closure. We're not going to get super into closures. There's a fair degree of complexity, but we will get to create one. And what we're going to be using this for is the ability to sort an array. And in order to do that, we actually need to pass a function in as a parameter to the sorted function. Let's see how this works. So let's create a new function. And we're going to do this at the bottom here. I'm just going to add a comment that says helpers. Give myself some space to work with here. And I'm going to say func sort by date. And we're going to say task1, task model, task2, and this was also going to be a task model. And this is going to return a bool. And we're going to just simply return here task1 dot date dot time interval since 1970 is less than task2 dot date dot time interval since 1970. And we'll talk about what's going on here. So we're creating a function here, and this function's name is sort by date. It has two parameters here. The first one is a task1 is named task1, and it's a task model. And the second parameter is named task2, and it's a task model instance. And it returns a bool. And basically this bool is going to be true or false. And what we're going to test here is the date interval, a time interval. This gives us an int value. So if we hold down the Alt key, we can see that this is going to return an ns time interval instance. If we click on this, let's bring us over to the library here. And for our purposes, excuse me, it's not an integer. We get a double back from the Swift here. So we're able to get back a value here, or a number. And because we're able to convert both of our dates into numbers, we can then do this comparison, right? Using the less than operator, or the less than comparison here. So we're able to say, is the time amount since 1970, January 1st of 1970, less than the time amount since date 2 since 1970. And if this is the case, we'll return true. Otherwise, we'll return false from this function, right? So we're just comparing two task models. We're saying, is one less than the other, right? Is the date less than the other? Well, there's actually a really cool thing we can do here. And that's we can actually drop a function inside of another function. This is called an embedded function. So I'm just going to go ahead and cut this, Command X. We just kind of wrote this out at the bottom here so we could see creating a function the normal way we do it. And we're just going to cut it and we're going to drop it right into our viewDidAppear function, because we're going to want to update our array every time we see our view on the screen. So it makes sense to do it in viewDidAppear. And we see that we get no errors here, right? Our compiler is not complaining to us at all. And this is, we're just defining another function inside of a function. This is completely legal to do in Swift. Now, we're going to go ahead and update our task array, and we're going to set this equal to task array dot sorted. And I want you to notice here that the style, or what it's asking for, mirrors what we just created, right? So it's ordered before some sort of name here, but then it has two different identifiers here, and it returns a bool, two different parameters here. So we have two different parameters, and it returns a bool as well. So we can simply do sort by date, and this is completely legal. We can now pass in this function as the parameter here when this function expects a function as its argument. And when we run our computer program now, we're going to see that our dates are now being ordered by their date property, right? So we're now able to update this array. You're actually able to see that animation as it was reloading and showing you that change. So this is a great reason to throw reload data in there. Now, this is still a little bit messy. We can actually clean this up even more by using what's called a closure. And what we're going to be doing here is we're actually going to be passing in all these different parameters into this parameter here. How does that work? Well, I think the easiest way to understand this is to just see it. So I'm going to go ahead and just write task array equals task array dot sorted. And we'll add curly braces. And then we're going to pass in our parameter. I'm just going to copy this down. So we're going to take our two parameters here. And we're going to return a bool. We're going to add this in keyword. And we're going to say comparison logic here. And we'll say return. And we can just use our return statement here. So let me just close out my console here, give us a little bit more space to work with here. And I just want to say that these two bits of code are equivalent. They might look a little different, but if we take a look at our function here, sort by date, we see that we're still using two arguments here. We're passing in two arguments. We see these curly braces, right? Which is we were required to add for our function here. Right, we have our curly braces here. And we see that we're returning a bool, that's fine. Now we have this in keyword that's a little bit different. But what this is going to allow us to do is when we add this in keyword, we're going to be able to add our comparison logic. And that's why I just added this comment for us. And we have the same return that we had before. So all we really removed was that func keyword, sort by date keyword or name. And then we also added this in. That's all that really changed. The curly braces kind of change spots as well. But this is a pretty cool way that we can shorten our logic up here, and we also don't have to have an embedded function, which I'm not a huge fan of, in order to get the same functionality, right? So if we comment this out, we're actually going to delete this in just a second. We are going to use the closure as our final code. We're going to see that this is still going to properly arrange our items by date. So again, all we're doing here is we're basically passing in what amounts to the function parameters and the return type here. And we're also passing in that our comparison should be based on the time interval since 1970. We return that inside of here, and then it's able to sort it based on these parameters. So it's actually going to compare each one of these items inside of our array for us. So it's going to abstract away a lot of this work we have to do. And just remember that these two are equivalent. Hopefully this syntax doesn't seem too crazy to you. All we're doing is just dropping in a function, and we're passing that function as a parameter. And here we're just kind of changing things around a little bit. It's something to remember. I realize we're going to have other experiences with closures in the future. They're one of the more complex data types. So if you're not completely comfortable with these, that's okay. But I did want to expose it to you and show you that, it's not the scariest thing in the world, and they're pretty cool. They give us access to a lot of additional functionality. So I can just go ahead and delete this, and we're now able to order our tasks by date.
Our task list is shaping up nicely, but it's time to make it even cooler by adding a section for completed tasks and allowing for tasks to be marked as completed by swiping on the row. As tasks are held in an array, will also be holding completed tasks in an array. But instead of having disjointed arrays floating around our project, we can create one base array that has two arrays as its objects or instances. This is also known as a multi-dimensional array, and we've seen one of these before when we worked on our weather inside of the lemonade stand project. So the first thing we're going to do here is we're going to want to go ahead and delete our task array here as a property. We'll be using an array of arrays later on, but for right now we don't need that. What we do want to do here is we want to make our task array a constant here. So make sure you add that let keyword in front of task array. All right, so we're no longer going to have our task array update our table view, and we're no longer going to be doing sorting on our task array. We're going to be using another array later on. The next thing we want to do is we're going to want to update our task model, and we're going to add an additional property here, and it's going to be called completed. And can you guess what type this is going to be? It's going to be a bool, right? Completed, or you could say even is completed, can be true or false, right? So our task is either completed or it's not completed. And what we do want to do now is we want to update our task model instances anywhere we're creating a task model instance. And we want to add that completed, I need a comma here, completed property. And let's set the default to be false for our initial tasks here. And finally, we want to do it for our task model down here. So with this additional property, we're going to be able to track for each task model instance whether or not we finished it. And that's kind of the base of a task list. So the other thing we want to do in this video is we want to create a property to replace the task array property that we removed at the beginning of the video. So we're going to go ahead and type var base array, and this is going to hold two arrays. Specifically, it's going to hold an array of completed tasks and an array of uncompleted tasks. So there'll be two arrays inside of the base array. So it's going to hold task model instances. Each array inside of our array is going to hold task model instances. And this is just what's known as a multi-dimensional array. We used one of these inside of the lemonade stand. So we're going to set this equal to an array, and then it will create it. And in our future videos, what we're going to do is update everywhere we see this task array being used to manage our table view and being passed around with our base array. Back in the view controller, we need to edit our viewDidLoad function to have two arrays, one for our incomplete tasks and one for our completed tasks. Then we need to add both to the base array property that we set up in our last video. So we actually have an incomplete tasks task array. We're just calling that task array. If you want to be more explicit, you could call it something like incomplete tasks or incomplete tasks array. But what we do need to do is we need to create an array for our completed tasks. So we're going to say var completed array equals task model, and we're going to say task. The first task will be code, and the second task will be, or subtask here will be task project. And let's actually add a space there to make that look a little bit nicer. And then we're going to say date, and let's just make it the same date as date 2 rather than going and creating a new date instance. And finally, let's go ahead and add completed. And remember that this is going to be true because we're in the completed array, so all tasks inside of the completed array should be true. And finally, add a parenthesis at the end here to finish our task model instance off. So what are we doing here? Well, we're creating a variable, and the variable name is completed array, and we're setting it equal to an array. We're using our literal syntax here, and it contains one task model instance that we're going to create with the task code, the subtask task project, the date we're going to reuse the date2 instance that we already created up here, and we're going to set the completed state to be true. The next thing we want to do is we want to create a base array, and we have a property here named base array, and we're saying that it's an array that holds arrays. So let's go ahead and use our array syntax here. And we have two arrays here. We have task array and we have completed task array. So we're adding both of our arrays here to our array, and we're setting that equal to base array. And this will work because both of our arrays hold task model instances, which is what we specified for our base array.
So we now need to do some additional updates now that we've added our base array instead of our task array. And the first thing we're going to want to do is we're going to update our UI table view data source functions. In fact, we're going to add an additional function so that we can have multiple sections in our table view. So let's find our UI table view data source and let's add our new function first. So we're going to add a new function and its name is going to be number of sections in table view. So if you just start typing that, it should autocomplete for you here. Usually we type like table view in first, but for this one, it's named a little bit differently. Don't ask me why Apple did that. So I'm not really sure, but I do know that we do need to implement this function. And what we're going to return here is going to be the count of our base array, right? So the number of sections we want to be equal to the number of arrays we have inside of our base array. Well, then for the number of rows in section, which is the next function we need to update, we're going to update the number of rows in a given section based upon the number of elements inside of the specific array, right? So we have two arrays here. We have task array and completed array. Task array will fill up our first section, which will be section 0, and completed array will fill up our second section, which will be section 1. And inside of section 0, we're going to have 3 elements, right? Task 1, task 2, and task 3 here. We're just creating task 3 inside of the array. So we're going to want to return 3 here. And in section 1, which would be our second section, we only want to return 1 because we only want 1 row for there. So how do we do that? Well, we're going to simply say base array, and we need to get one of the arrays back. So we can index into our base array by passing in section, right? And section is just going to be the section number. If it's section 0, which is the first section, okay, give me the first array back. If it's section 1, which is going to be our second section, we'll index into our base array. We'll say, okay, give me the second array back, which will be our completed array. And with our array being returned, we can next access the count property to tell us how many elements are in the array, and this is how many rows we should have in this given section. So we're going to return base array. We're going to access the section from our parameter here. And we're going to basically say, okay, give me the array at this specific index. And then we're going to access the count property to tell us how many rows we should have. Then we can update this task with the base array by saying that we should use base array. Let me just add a return here. Base array. And then we're going to index into this using indexPath.section. And then we'll index into this using indexPath.row. So what's going on here? Well, we're indexing into the base array the same way we did before. We're just accessing the section, but in order to get the section, we have to access the property of indexPath. So we're saying, okay, first give me an array back. That's what this is equal to. And we're going to get back either our task array or our completed array. And that will be based on the section. So self-row at index path will first be called for section 0, and it'll tell us, okay, well, in section 0, which is our first section, we're going to have 3 different rows. So self-row and index path will be called 3 times. And each time this section will be 0, so we'll get back our first array. And then from our array, we want to get back a task model instance. So we're going to do indexPath.row the same way we've accessed elements from arrays in the past. Then when we get to the second section, indexPath.section will be 1, and we'll be able to get back our second array. And from that, we'll be able to get a specific task model instance. So that's the only adjustment we need to make to the self-row at indexPath function. Let's also go update the prepare for segue function, which is another error we have here. And once again, in order to get back the task model instance, we're going to access this from our base array, not our task array. So we're going to say base array, and we have an index path. And once again, we can do index path dot section, and then we're going to do index path dot row. And sorry, I need an exclamation point here, because remember, in this case, index path is an optional, so we have to use the exclamation point to actually unwrap it. And in this case, once again, right, we're going to access an array from our base array, be it our task array or our completed array, and then we'll actually access a task model instance from that array. So we're just kind of chaining these two elements together to update the prepare for segue function, and we're going about this the same way we did in this helper row at index path function that we did down here. So we still have a few additional fixes we need to do in our project in order to get this working with our base array. So the first thing we're going to want to update is in view did appear, we're going to update the task array.sorted. We're only going to sort our first array. We're not going to worry about sorting our completed tasks by date. So we're going to simply access the first array by saying base array 0, and then let's update this by saying base array, let me just properly highlight this here, base array, and we'll do 0, make sure you put base array in there properly, dot sorted. And this is going to work the same way. Now, if you wanted to update the second array in the base array, you could just do base array 1, and you could even use a for loop if you wanted here, iterate through the arrays and update them. We're only going to do the first array to be sorted. That's fine. It has 3 elements. So we'll still be able to see this sort logic we wrote, but we're eventually going to do some refactoring with core data, and this is going to be a completely different way we're going to go about sorting. So we're actually going to remove this code altogether in the future. So in order to get this application to work right now, we're just going to hard code in that we're going to index into the first array using index 0. So the second thing we want to do is we want to update the task detail viewcontroller.swift file. And right now we need to update our task model so that we can properly show off the completion. So we're going to set the completion to false. So we're going to do completed : false, right? Because right now we now have a complete task model instance. Before we had the completed state, right? It was an incomplete task model instance, so we had an error. And the second thing we want to do here is we want to update our main view controller's base array, not our task array, right? We remove task array as a property. So we're going to do main bc dot base array, and then we'll just do 0, right? Because we want to add this to the first array inside of the base array. And now our task detail view controller will be properly updated. So hopefully that wasn't super confusing. All we did was access the base array instead of the task array, but we still want to add this to the first array, which has the uncompleted tasks. So we're going to just say base array 0. Finally, we want to update the add task view controller. And in here, once again, we need to finish creating our task model instance. So we'll do comma completed : false. And then in order to add this element to our base array, we're going to say base array 0 dot append task, right? So we're going to add our new task to the first array inside of our base array. Now let's go ahead and run our application and see if all of these changes are working. So we're now going to see that we have eat dinner, study French, and gym, and code is now appearing at the bottom. But we don't really have a differentiation between our two sections, right? Both of our sections are populating. And if we add an additional task, let's just call this task test. We'll say this is a test. We can add our task here. We do see task is appearing in the proper section, right? It didn't appear at the bottom. And it is also automatically dating this properly. But once again, we don't have a differentiation. So in our next video, we'll figure out how to add headers so that we can figure out which is our first section and which is our second section. In this video, we're going to add two UI table view delegate functions, which are going to allow us to add headers to each one of our sections inside of our table view. Why do we have two? Well, the first function we're going to need to specify, we're going to do this inside of the viewcontroller.swift file under the UI table view delegate comment here. We'll start typing in table view, and we're going to look for height for header in section. And we're going to return 25 from this. And what this is going to allow us to do is set the height for our header in each section to be 25 points large. So we're going to have a pretty sizable header here. But this won't actually display any information. What we need to next implement is going to be table view. We're going to start typing that in, and we'll search for title for header in section. And we notice that this function returns a string. So we're going to be able to return a string for each header. Now we want two different headers. So we're going to use some control flow here. We're going to say if section equals 0, if we're in the first section, we're going to return to do. Otherwise, we'll add an else below this. We'll return completed. And let's go ahead and run our application here. And we now see that we have headers, to do, and completed, and it gives us some differentiation between each one of our sections. So it's a lot easier to see this inside of our application. So our functions work properly. We were able to implement two functions here. The first one was able to determine the height of the header. And in our second one, we just have to return a string. Now we use some control flow. So we'd have different string titles for our first section versus our second section. So right now we have no way of allowing the user to change a task from being uncompleted to completed. So we want to add this functionality, and to do so we're going to allow the user to swipe in our table view. So right now all we can do is click. We're going to add that swipe functionality, and when they press delete we're going to allow them to switch a task from being completed to being uncompleted to completed. So let's go ahead and add an additional function here. We're going to add, again, under the UI table view delegate comment here in the viewcontroller.swift file. We're going to start typing in table view, and we're going to look this time for commit editing style. So it's towards the top here. Commit editing style. And this function allows us to immediately add the ability to add swipe. And it also asks what should happen to a cell that's swiped. So we're going to first add some code here. We first want to access the specific task that was being swiped on. And when the delete button is pressed, we're going to be able to figure out, okay, this is the specific task where we press delete. So we're going to let this task equal base array. And we're going to get back this task. The same way we did in self-row and index path, which is this task dot section, and then we'll do index path dot row. So we're able to access first an array from our base array, and then we're going to index into that array using index path dot row, the same way we've done in the past. So with the task in hand, we're going to create a new task. We're going to say var new task is equal to task model, and we're going to update each one of these properties with this task we just got back here. So we're going to say this task dot task, and we can say this task dot subtask, and then we'll do this task dot date, and we'll do this task dot completed. Well, do we want to use the same completion we just had from this task? No, actually we want to switch it from being uncompleted to completed. So let's just set completed to true for now. And you might say, okay, well, how are we going to be able to switch from completed tasks to uncompleted tasks if we're hard coding this to true? And the answer is we won't be able to yet. We'll figure out how to do that in our next video. So that's upcoming. The next thing we're going to do here is we're going to update our base array. So we're going to say base array index path dot section, and then we're going to do dot remove at index, and we're going to do index path dot row, And then what we'll do here is we'll type in base array 1, index 1, dot append, and we'll pass in new task. And finally, what we'll do here is we'll say table view dot reload data. And let's talk about this code we just wrote here. Well, we have a new task, and we're using this task we got back from our base array in order to update each one of the properties except for the completed. We're just setting that to true for now. And then what we're doing is we're updating our base array. So we're first going to remove the task that was swiped on, right, if we're in the first section, or the second section, whichever section we're in here, based on index path.section. We're going to remove the task model instance saved in our base array based on the index.path.row. So whichever one we're swiping and pressing the delete button on, we're going to go ahead and remove that from our base array. And then we're going to re-add the task to our second array in the base array, right? Index 1. We're going to add a task there. And then we're going to call reload data, which is going to basically say, okay, now refresh all the information in our table view. So let's see if this works. Let's go ahead and run our application here. And let's swipe on eat dinner, and we can press delete. And we can now see that eat dinner is moving down to our completed section. So this new function, remove at index, allows us to remove instances at a specific index in an array. Now let's allow our users to uncomplete tasks. To do so, we're going to be updating the commit editing style function inside of the viewController.swift file under the UI table view delegate comment that we added earlier. And what we're going to do here is we're going to add some control flow. So we're going to say if index path.section is equal to 0. And then what we can do is we can just cut and paste this code into here. And what is this? Well, we're just basically saying that if the section is equal to 0, we want to mark this task as completed. The one bit of code that we're going to want to keep down at the bottom here is this base array remove at index, and we're going to move this right below or right above our table view.reload data. And we'll see why in just a second. What we're going to do is we're going to add an additional line of code here, and we're going to say else. And you could add an else if there were multiple sections. We only have 2 sections, so else will work fine here. And we're going to say else var new task is equal to task model, and we'll do task this task dot task. Subtask will be this task dot subtask, and date will be this task dot date. Finally, we want to update the completion to false, and then we're going to add this not to the second array but to the first array. So we're going to say base array object at index 0, and then we're going to do dot append, and we'll pass in our new task. So what we're doing here is we're basically saying if the section is 0, go ahead and create a new task and append it to the second array. If we're in the second array, right, if we're in the second section, go ahead and create a new task, set its completion to false, and add it back to the first array, or the array at index 0 here. Either way, we want to go ahead and remove the old task remove at index here using this remove at index function, and then we want to reload the data. So notice that we're still able to keep this line of code, this task where we originally got the task, and these 2 lines of code. And the only thing we're going to do is we're going to switch the new task, and we're specifically just switching the completed state, and then we're going to pick which array we want to add this to, be it array 1 or array 2. So in this way, we're able to reuse some code. We don't have to copy and paste all of this code. We only have to make this change for these 2 lines of code depending on which section we're in. So let's try running this and see if we can uncomplete some tasks. So we're going to go to the completed section, select delete, and it'll move our task up to our uncompleted tasks section. We're going to be
updating our project to use core data in the coming videos. And specifically what we're going to be doing is we're going to be removing this base array. We're going to be removing all of these preceded tasks. We're even going to be able to remove this reloaded data functionality because we're going to be using core data with an NSFetch results controller in order to save items locally to our file system. And we're also going to be able to have our table view automatically update based on our NSFetch results controller. This is going to be a super optimized way in which we can interact with core data. Now, because core data is such a complicated topic, we're going to see this in multiple applications moving forward. So we're going to have tons of chances to practice with this. Using NSFetch results controller is only one way that you can interact with core data. So we're going to see a bunch in the future throughout our other projects. So what we're going to do in this video is we're just going to clear out viewDidLoad, and this is going to give you an idea of how many items are going to break inside of your project. And hopefully you'll see that we have quite a bit of changes we need to make. The idea of refactoring once you create projects is really common when you're building out larger applications. You kind of get things to work and then you decide you want to change things around. So being comfortable changing code is actually a really good skill to develop. We're now going to set up core data, and before we get started writing any code, we actually need to add an additional framework. Now, frameworks are just a library or a bunch of code that's written by Apple, and they don't automatically include it because there's a ton of different frameworks, and we don't need every framework in every project. So in order to keep things a little bit more lightweight, we have to add this manually ourselves. So we're going to select our project here, and we're going to go to Build Phases, and we're going to select the option to link binary with libraries. You should now see this plus here. We can press this plus, and we're going to see that there's quite a few frameworks in here. So this is going to be one of the first frameworks we're adding here. There's Metal. This is awesome for making games. PassKit. You've probably seen some of these items before. Quartz Core is really popular if you want to add shadows to your UI elements. But what we're going to be looking for here is the core data framework, and we're just going to select Add. Now, if we had generated our project with the core data option selected, it would have automatically done this for us. Since we're adding this manually ourselves, we actually have to add the framework ourselves. So this has added the core data framework. We now see this in our project. So as long as you see that, you know it's working properly. I'm just going to drag this down to supporting files. You could also create an additional grouping for frameworks if you were adding quite a few of them. We're not going to be adding that many, so we only need to drag that down to supporting files. Now, the other code we're going to be writing is in our app delegate. We haven't really touched the app delegate before, so I just want to quickly explain what the app delegate is before we get into our project. The app delegate is really useful for figuring out when our application is launched. We actually see there's a function did finish launching with options, so we can set up some global options for our entire application here. We can also get callbacks or have functions called for us when our application enters the background or when it enters the foreground. So we can figure out, okay, so the user has pressed that home button, my application is going to enter the background. I better do some saving, or maybe I want to persist some state, maybe save some settings for the user. There's a whole bunch of things we could do. And then you can also find out, okay, well, my users already used the application in the past. The application is going to re-enter the foreground. And in this case, I want to set up some default views. Maybe I'll transition to a specific view that they were last looking at. There's a whole bunch of different things we can do with this. And also application become active, application will terminate. You can kind of read the comments here and it tells you exactly what happens. We're not going to be using these, but I just want you to know that they're available. Now, the reason we're going to be writing our core data code here is we can gain access quite easily to the app delegate in all of our classes inside of our project. So we're going to need to be saving and creating different entities, we're going to call these. This is a way we can model our classes. In the future, we'll figure out we can set up like a schema. And in this case, we're going to be able to access the app delegate in order to get that functionality in all of the different classes that we need it in. So it's a really good place to set up kind of this global access for our project. So the first thing we're going to do is we're going to go to the top here and we're actually going to import that core data framework we just added
into our supporting files. And this will give us access to all of the functionality inside of the core data framework. So we actually haven't done really our own import statement yet, I don't believe, in this class yet. So importing here is basically saying, okay, I actually want to include that framework. And if we don't import it, we won't be able to see all of the different functionality inside of that framework. So it's important that we import it. We get a lot of default imports, importing UIKit, all of our UI elements. We've imported Foundation in the past. It's given us access to the Swift programming language, also the Objective-C programming language if we needed it. The next thing we're going to do is you're going to go over to the lecture notes. This is going to be one of the few times I'm going to actually have you copy and paste something, but this code would be generally generated by the boilerplate code when we select the core data option. In our case, we're going to copy and paste this in so you can see what is being generated when we do select that option. And hopefully you'll understand a little bit better what each function does. We're not going to go line by line with this code, so I'm just going to paste it, and I already have it on my clipboard here. And the reason we're not going to go line by line, you would never really write this code out, right? I mean, there might be a few use cases where you have to write this out yourself, but generally you're going to select that core data option and you wouldn't write this all in, right? But we should at least understand what's going on here so we have a better idea about what the core data stack is. So the first item here is our applications document directory. And this is basically where Apple is going to store our core data store file, or actually like our database, right, into the file system. So we're actually going to be able to store our entities, which are going to be able to model our objects. I know it sounds a little bit confusing, but we're going to be able to essentially store encapsulated pieces of information or store actual instances of our class into our file system, which means that we're going to be able to access this later in between sessions. So you turn off your phone, you turn it back on, you're going to be able to save this stuff. And where we're saving it is down to our applications document directory. And this kind of gives us a way to access that specific application directory. The second thing we have here is an object model, or managed object model. And you can kind of think about this as a database schema. We're going to be able to define a bunch of entities, and entities we're going to kind of use interchangeably with classes. Specifically, an entity allows us to save this information to core data, but we're still going to be able to add attributes, access those using the dot notation, pretty much interact with them the same way we've done so with other classes in the past. We're not going to add a ton of functionality on top. We're not going to be defining a bunch of functions inside of the entities. But we will be able to, model our information with the entities. And that's really the purpose of an entity here. So our managed object model is going to allow us to set this all up. We next have a persistent store coordinator. And the persistent store coordinator is kind of a database connection. You can set the actual names and locations of what databases will be used to store the objects. And if that seems a little confusing, this is just going to be something we have to set up. We're going to use this like once or twice, and it's just going to allow us to interact with the database. So not super heavy use on the persistent store coordinator. What we will be using a ton is the managed object context. And the managed object context is basically a scratch pad for entities that will be able to call things like save, or we'll be able to call things like delete or create an entity, and we're going to do this all against the managed object context. So we're going to be accessing this managed object context from our app delegate quite a bit. So you're going to see us do that in code. And as you use the managed object context, it'll seem less and less scary as we just access this specific instance of the managed object context from app delegate and call things like save, etc. We also have save context, which allows us to save changes that we've made to an entity. So this is going to be really handy, being able to save, I want to update this property and call save. Save context is a really important function that we're going to be using quite a bit when we make changes to our core data entities here. Incidentally, I just want to quickly point out that the persistent store coordinator, you could theoretically have multiple persistent store coordinators if for some reason you had multiple persistent stores or multiple databases.
The odds of you doing that are pretty low. There are some use cases in pretty advanced applications where you will see that, so it is possible. But for our purposes, we'll only be using one persistent store coordinator instance. Now, you might be sitting there and saying to yourself, wow, this is super overwhelming. There's a ton of new code we just added. I don't understand anything of what you just said. And that's completely okay. We're going to go through core data together. You're going to see it's not super scary, assuming you know the steps in order to create an entity and set it up in an entity. And we're going to be using core data in quite a few projects moving forward. So be plenty of chances for you to practice this stuff. I know it's super new and there's a bunch of code, but once we get to using it, it's really powerful functionality to be able to save different entities into core data, because then our application isn't reliant on having an internet connection. It isn't reliant on the user re-entering everything every time they open up our application. We can start saving things, and that's really important for building iPhone applications. So we need a way to set up our schema, and in order to do so, we're going to add an XC data modeled. So we're going to select File, New File, and we're going to choose iOS Source, Core Data, and we'll choose Data Model. And we're going to call this Taskit Model. And we can create this. So we're going to see a brand new item here. It's going to be Taskit model.xc data modeled. And I'm just going to drag this down right above my storyboard here. And there's one thing we want to change immediately, and that's in our app delegate. And I'm going to point this out in case you do this process again yourself, you create this manually. When we copy and paste the code in, we had this nsbundle.mainbundle.url for resource in our managed object model. And once again, I'm in the app delegate.swift. I'm taking a look at this boilerplate code I pasted in. And when I created my project, I'd created another project and we pasted this in. I called it Taskit, right, which matched up. But if you select the core data option, it's going to call it taskit.xc data modeled. Now, because I created this myself, I used my own custom name. So I want to update this URL for resource to match the name I just added. So all we have to do is change this to Taskit model. But it's really important to understand that this name needs to match up to what we created here. These names need to match up so that we can locate this file, right? So that the managed object model is going to be able to locate this. So let's go back here to our task model.xc data modeled file. And we see that we have kind of an empty screen here. We're going to be able to create an entity, and our entity is going to be used to replace our task model. So let's press add entity, and we can change the name of this entity. We're going to call this task model. And when we generate this entity, we'll actually see that it's going to be named task model. So whatever we change this entity name to is what we'll be able to generate the name to. And we can add some attributes, and these are going to work very similar to our properties that we've set up for classes or structs in the past. So let's name our first attribute completed, and we'll say this is going to be a Boolean. And we can add an additional one. We'll say this is going to be the date, and we actually have a date type here. And then we'll use subtask. Subtask. And this is going to be a string. And then let's add a task, and this will also be a string. So we see here that we are able to create these attributes, and we can think of these like the properties we previously had in our task model. If we take a look at our task model, right, we had task, subtask, date, and completed, right? So that matches up. We also notice that we're using lowercase here, right? We've always done that with properties in the past. And we also notice that we use an uppercase letter here. And we've always done that with class names or struct names in the past. So we've now created an entity. How do we actually get that in here? Well, the first thing we're going to do is we're going to delete our own old task model.swift file. We no longer need that. And it's important that we choose to move this to the trash. We no longer want to see this. We don't want to leave this file in our project even though it will no longer be targeted. Let's just move this to the trash and get rid of it completely. And let's go back to our Taskit model. And we're going to make sure we have our entity selected here. We can go to Editor, and we're going to select the option to create an NS Managed Object subclass.
and this will generate a new file for us. We're going to make sure we have task model selected here, and we can go to next, and we're going to choose our entities. So we're going to choose task model. We're going to make sure we press next, and we are not going to check the option to use scalar properties. We are going to switch this over to Swift, and we're going to make sure our targets is task it. Very important that we make sure we switch this over to Swift. Now we can select create. So we're going to get a brand new file here. Now there's one little change we want to make to this file, and it's not really required, but it's pretty cool in case you ever want to interact with Objective-C and your task model. And we're just going to add a bit of code here. It's going to say Obj-C, and we're going to say task model. And this just creates an Objective-C bridge in case we ever want to use Objective-C with our entity in the future. So I highly recommend you always do this. It's always there. If you get in the habit of remembering to do this, if you ever want to use Objective-C later, you won't run into errors when you're trying to interact with it and be confused. So that's all for this video. In our next video, we're going to figure out how we can actually create and access a task model. It's a little bit different than we've done for classes in the past. So we're going to get started creating a task model entity, and then we're going to figure out how we can access all of our task model entities once we start creating them. Although we won't be able to test that just yet because we have quite a few errors in our code, at least you'll know the process and you'll kind of be able to see the two side by side. So this is how I create it, this is how I get it back. The first thing we're going to be doing is we're going to be updating our add task button tapped function. And we're going to specifically be removing these two lines of code here that I've highlighted in add task button tapped. And the reason we're going to be removing this is we're no longer going to be able to create a task model using our old initializer here. We have to now create our core data entity, and we're no longer going to be appending this to our base array. We're actually going to be using an NSFetch results controller in the future in order to access our elements rather than storing them all in an array. So we'll see how to do that in our next video. For this video, we just want to figure out how do we create an entity and then how do we get it back if we want to do a request or a fetch request for it. So let's go ahead and delete this code here. And the first thing we're going to do is we're going to get access to our app delegate. I mentioned that in our app delegate, we have our managed object context, that our app delegate is accessible to all of our classes. So how do we get access to it? Well, we can write let app delegate, we're going to make this constant, equal UI application dot shared application dot delegate, we'll say as app delegate. So what is this going to do? Well, UI application represents our entire application, and it has a property named shared application, and from that we can get the delegate. And this delegate, right, happens to be our app delegate.swift file, right? It represents an instance of our app delegate. So we're able to access that because we have access to the entire application, right? UI application represents the entire application. If that's confusing, hold down the Alt key and press on UI application. And you can kind of see here the way Apple describes this. It's a class that provides a centralized point of control and coordination for apps running on iOS. So we only have one instance of UI application inside of our entire application here, our entire computer program. Now, shared application, right, returns a singleton of the app instance. Now, a singleton means that there can be one and only one instance of this application inside of the entire computer program. It's impossible to create more than one. So as I said, from that, this delegate property is automatically set by Apple, and it gives us access to an instance of our app delegate here. We can then access our managed object context from our app delegate by saying let managed object context equal app delegate dot managed object context. And where is that coming from? Well, if you look at your app delegate here, we have our managed object context, and we're just accessing this, right? We're accessing this variable. So nothing too crazy, just getting that back from our app delegate. And the next thing we need to do is a little bit more complicated. We need to say let entity description equal ns entity description, And we see that this isn't auto-completing, right? We're getting an error here. Why is this? Well, we haven't imported the core data framework. So NS entity description is defined in the core data framework. We don't have that right now. So let's go to the top here and let's import core data. And now when we go down here, we see NS entity description is now purple, right? We now have access to this. So we can do .entity name. And what is our entity name? Well, it's our task model, right? We set up an entity in our taskget model. So now we just enter a string for our entity name here. We're going to write task model in, and it's going to say in managed object context. Well, we get our managed object context from this constant we just created, and we got that from our app delegate. So we just put that in there. So one thing about our managed object context here is it's actually an optional. So we actually have to add an exclamation point to our managed object context. So we'll just add an exclamation point here, and that will fix our error. So the next thing we want to do is we actually want to create our task instance. So we're going to say let task equal task model. We're going to say entity, and we'll use our entity description here. And we have to use an exclamation point. This is an optional again. And then we're going to pass in our managed object context. And once again, it's an optional, so we have to unwrap it. So we'll add an exclamation point. So what did we just do in the last 2 lines of code? Well, we created an NS entity description. And the NS entity description basically allows us to map an entity to our persistent store. If that sounds a little confusing, basically we need this thing in order to create our task model. Now, I know I'm simplifying a lot of what we're doing in core data. I mean, I highly recommend as you get more into core data, you take a look at the Apple docs and stuff. But I'm really trying to keep this a little bit simple so we can just figure out the steps in order to do this. There's just some steps you need to understand and, kind of do back and practice, and then you're going to be able to do this yourself without too many problems. So basically what we do is we create an entity description constant, and all we have to do is pass in our entity name and a managed object context. We got that from our app delegate. Then we're actually able to create our task model instance, right? And in the past, we've had to do this by, just initializing, or we can initialize it with some values. But now we do this by passing our entity description, right? Which is going to allow our entity to go properly into our persistent store or through our persistent store. And then we're going to be able to insert this into the managed object context. And we now have an entity that we can start setting the properties for. So we can access these properties the same way we've done in the past. We can say task.task is equal to task text field.text. Right, and this should look pretty familiar. When we created our task model, we did something like this before. We can next set our subtasks. We'll say task.subtask is equal to subtask text field.text. And task.date is going to be equal to due date picker.date. And task.completed, and we'll set this initial state to false. The reason we're going to do this is, if our user is just adding a task for the first time, we're going to assume that they want it to not be immediately completed. We can then use our app delegate. So we're going to say app delegate, and we're going to call the function save context. And this is going to save any changes we've made to our entity. So if we make a change down here below this change will not be saved. We got to make this change before we call this function save context. And once again, this was defined inside of our app delegate, inside of that boilerplate code we added. And actually what's really cool is it's actually going to tell us if there's an error. It'll actually print that out to our console if there's some error saving this. The next thing we want to do, and hopefully that wasn't super confusing. Yeah, there were a few new steps here, but it's just a different way we're going to create this entity. We're still setting the properties the same way we've done in the past, and then we just call this cool function save context. We're next going to show you how can we get back all of the entities of a specific type we've created. So we had like 3 or 4 entities here. We can make a request for one type at a time. And we could add additional constraints on it. But for now, we're going to just focus on how do I get back all of the instances of the entity I've created. So if I created 30 task model instances, I would get back 30 task model instances, and that'll actually be given back to me in an array. So the first thing we need to do is we need to create an NSFetch request. So we're going to say var request, and then we're going to make this an NSFetch request. and we're going to pass in the entity name here. So it's going to be task model. And this is going to basically say, okay, I want to request all entities of task model, or all instances of task model. We next can create an NSError instance. So we're going to say error, and we'll say NSError. And we're going to set this equal to nil. And then we're going to say var results, and we'll specify this is going to be an NSArray. We'll set this equal to managed object context dot execute fetch request. We're going to pass in our request here. And we're going to do ampersand error, and we're going to do exclamation point at the end. And finally, we'll explain what this code is in just a sec. We'll do for res in results print line, and we'll do res. So what's going on here? Well, we're creating an NSFetch request, and this request is going to say, okay, now I'm going to specify the entity name is a task model. So request all instances of task model. We next create an NSError instance, and notice this is an optional, and we're going to set this initial value to nil. Why do we set this to nil? Well, we're only going to assign error a value if there is an error. And that's the reason we have to use this ampersand down here. This is going to say, this is actually a memory location. We're actually passing it like an address. And we're saying, okay, write the error to this memory address. And if that seems a little confusing, it's an optimization. Basically, we don't want to just create this NSError if we don't need it. So this is the way we optimize here. So it's just a little something you have to remember when you do this error. You're going to put this ampersand in front of it. What we are doing here is we're saying results is an NSArray, and this is an Objective-C type. So we're forced to specify that this is an NSArray. This is the array type we're going to get back here, but we're going to be able to use this array the same way we've used arrays in the past. Specifically, I show you down here that we're able to do a for in loop here. We can say for res, which would be one of the entity instances we get back, and we would iterate through all of the instances in results, because results is an array, right? It's an NSArray in this case. And what we're doing here is we're able to call this function execute fetch request on our managed object context. This is an optional, so we have to unwrap it. And we're going to say execute fetch request. And the reason we have to unwrap this whole thing here is there is a chance it can be nil, right? We could return no instances back. So we're going to unwrap it here. I'm going to say, okay, give me back whatever values you get, set it equal to results. And if we have some values, we'll set it equal here. And we'll pass in our requests. So we're actually telling our, we're telling our managed object context to, okay, go and access all the instances of our entity here. So this is the way we can create an NSFetch request. We're going to create more NSFetch requests in the future, but I just want to show you how we could get back all this information now that I've showed you how we can create an additional entity as well. So it's nice to see both kind of in the same spot side by side. I know right now we have quite a few errors popping up, but before we get started fixing these, we're going to start by making two additional changes to our view controller. And we're going to basically be setting up our fetch results controller, which is going to manage doing our fetch request and updating our table view with the information we add to our task model or save from our task model. So the first thing we're going to do is we're going to import the core data framework, and we're going to do this in our viewcontroller.swift file. So we're going to import core data. And then what we're going to do here is we're going to say let managed object context equal, and we're going to say UI application dot shared application dot delegate, and we're going to say as app delegate, and then we'll do dot managed object context. And what this is going to do is it's going to give us access to the managed object context. Before, when we did this in our add task view controller, we kind of just broke this out and we got our app delegate first, and then we got our managed object context from our app delegate. Now we're just kind of chaining this together and doing this all in one step here. So we're going to be able to, use our managed object context to make updates to our entities. So it's really nice to have just this constant. So rather than having to write this code over and over again in our view controller. We're also going to set up our fetched results controller here. So we're going to say var fetched results controller. We're going to specify this is an NSFetched results controller. We're going to set this equal to NSFetched results controller. just an instance. That's all we're doing here. We're going to be able to access this and update properties of our fetched results controller inside of our functions. But for now, what we need to know is our nsFetchResults controller is going to be an optimized way we can manage updating our table view with changes to our core data entities. Now, the next thing we want to do is we want to set up a fetch request. We've done this in the past, right? We did this in our add task view controller. So I'm just going to add a comment at the bottom here. Now we can say helper. And what this function will do is it'll return an nsFetch request, and we're going to set it up to look for all our task models the same way we did in our add task view controller. But what we're going to add here is a sort descriptor. So it's going to automatically return all of our entities sorted by a date. So let's set that up. We're going to say func task fetch request, and we're going to say it's going to be return an nsFetch request instance, and we're going to say let fetch request equal, and we'll say nsFetch request, and we'll specify the entity name is going to be task model, same way we did in the past. But now what we want to do is we want to create a sort descriptor, excuse me. So we're going to say let sort descriptor equal ns sort descriptor. We'll say key is going to be date, and we want this to be ascending. So where is this key coming from? Well, if we take a look at our task model, we have a property date here. So our date here is going to be the key that we use to sort it. So it's automatically going to look at all these properties, it's going to sort it, and it's automatically going to make it ascending. So this is going to work great. But our fetch request doesn't yet know about this sort descriptor. So how do we connect the two? We're going to say fetch request.sort descriptors. And notice when we start typing in sort descriptors, let me just do that one more time. Sort descriptors, we see that it expects an array of any object. So we're going to have to say sort descriptor inside of an array here. So what this allows us to do is we could have multiple sort descriptors if we wanted to sort by a date and some additional property at the same time. You know, we could do a bunch of them. But for now, we're just going to do the date. That'll be enough to prove that we understand how to use a sort descriptor. The final thing we want to do from this function is we want to actually return our request, our fetch request here. So this will set this up. We're going to call this function just a bit. We want to set up one additional function while we're setting up helper functions. And we're going to do this a little differently than we would normally do this. I'm going to kind of encapsulate this and show you how we'll do this. I'll show you what I mean here. We're going to say func get fetch results controller, and we're going to set this equal to an nsFetched results controller instance. And let's add our curly braces so we can actually write this function. So what we're going to do is we're actually going to add our property here, and then we're going to call this function and set it equal to it. So we're going to kind of update our property twice. Not really required, but I want to show you, how we could go about doing this. So we're going to do fetched results controller is equal to nsFetched results controller fetch request. And where are we going to get our fetch request? Well, we can just call our task fetch request we just set up. That's what we spent all that time doing it. So we're going to say task fetch request, and then it's going to ask for a managed object context. Well, we set up a property already that was named managed object context, so we're good to go there. And then we need a key path, and we'll just set this to nil and the cache to nil for now. So what I mean when I said this was a little weird, right? We're actually going to call this function, and we can go ahead and do this right now. We're going to go up to view did load here. And we'll say that the fetch results controller, remember this is a property, fetch results controller, is equal to get fetch results controller. But we're actually updating this property already inside of this function. So we could make this like a local variable. You could make this, you could say var fetch results controller, and then actually go ahead and return the fetch results controller here. Right, and either way, we have to return the fetch results controller because this function expects you to return an instance of fetch results controller. But we might as well just update the property. I just want to show you both ways we could go about doing this, right? When you're adding helper functions, it's kind of on you to determine if you want to return something or if you want to just update the property directly inside of this helper function. So you can kind of see both ways. Hopefully that makes sense, what we're doing here. So what are we doing in this fetch results controller as we're setting this up, right? Our initializer here. Well, we pass in a fetch request, and we know that our fetch request is going to access all of the task model instances, and it's going to sort it by date. So our fetch results controller now knows, okay, I'm going to be responsible for looking at the task model instances and looking for changes there. Whenever there are changes, I'm going to order them by date as per the NSFetch request I passed in. How am I going to do this? Well, I'm going to do this with the managed object context. Remember, this is our scratch board where we're going to be able to make changes or see changes, request changes to our entities. So I'm going to pass in the managed object context, and I'm getting that from the app delegate. And right now, I don't need a section name key path or a cache name. We're not going to be caching things. But we will be using the section name key path in the future. So we're going to leave that to nil for now, but we will be updating it. And when we update it, we'll figure out what's going on there. We have a little bit more updating in this video, and then in our future videos, we'll be able to fix all these bugs we got in our project right now. And that's in view.did load. We want to finish setting up our fetch results controller. So there's 2 additional lines of code we have to set up here. We're going to say fetch results controller dot delegate is equal to self. And hopefully when we have this delegate property here, you can guess that that means we need to conform to some sort of protocol. So let's scroll up here, and we're going to conform to the NSFetched results controller delegate. And this is going to do the same thing we did with our table view. It's going to give us access to some additional functions. And our table view, we were able to set the delegate and data source property of our table view in our storyboard, but I did show you that there was a delegate and data source property on our table view that we could set equal to self. So in this case, we don't have this in our table or in our storyboard, so we have to do this manually in code. And what we're basically saying is, okay, the NSFetch results controller delegate is now able to call functions in this specific view controller. So it knows that this view controller instance or self exists by setting this property delegate equal to self. And in the future, we're going to be able to implement some functions from the NSFetch results controller delegate in order to properly upload or refresh the information in our table view. So that's why we have to set the delegate property equal to self. Now, the final step we have to do is we're going to say fetch results controller dot perform fetch, and we can just leave our errors in that. We could pass in an NS error instance and grab some information, but we're going to keep this a little bit simple. We're going to have more examples with core data in the future, so we're trying to keep this project from getting super huge. And as a result, we can just pass nil, and we don't care about an error. We're not going to be getting one from our project right now. We're going to keep this a little simple. So perform fetch basically is going to go ahead and say, okay, now that I've set up this fetch results controller, I've set up what it's looking for. I've set up that it can gain messages or have functions called from the NSFetch results controller delegate. I'm actually going to tell the fetch results controller to go out and start monitoring for changes to core data and actually go ahead and grab the initial batch of entities for the task model. So that's why we set this perform fetch function, or why we use the perform fetch function. Now we want to go ahead and revise a bunch of our functions. Specifically, let's go ahead and remove this var base array, because we're no longer going to be using this. We're going to be accessing all the information from our fetch results controller. And this is going to cause some more things to break. So the first thing we're going to take a look here at is the number of sections in our table view. So we're no longer going to do base array.count. We no longer have a base array. But what we do have is a fetch results controller. So we can say fetch results controller. And then how are we going to access the number of sections? We're going to do .sections !count. And this is going to give us the number of sections that we've been able to access from our fetch results controller. It knows how many sections there are. And then we're going to call the count property on that to figure out, okay, there should be 2 sections in my table view. So fetch results controller is working a lot like our base array here. In fact, we can say fetched results controller dot sections !section, and then we're going to do dot number of objects. And this is going to look a little similar to what we did with our base array. Before, we just did base array dot sections and then we figured out which section we were in, and then we did dot count, and now we're just doing number of objects. So it's a little bit different, right? It sounds a little bit different, but we're doing the same thing, right? We're saying, okay, given a specific section, right, we're going to pick section 0 or section 1. How many objects are there? Or how many rows should I populate in that given section? So we can next update the self row at index path. And once again, we have base array here. So we want to remove that. And we want to use our fetch results controller instead. And once again, this is going to look very similar to what we did before. We're going to say fetched results controller. We're going to use a slightly different function here, though. We're going to use a function called object at index path. And this expects an argument of index path. So we can pass an index path. And then we can do as task model. So what this does is it saves us from having to do indexPath.section, figure out which array we're looking at, and then do indexPath.row. We just pass in the index path, and it figures out for us, okay, which section, which row, and returns the correct task model instance. But it doesn't know what type of instance it's going to return here, so we have to specify that it's a task model instance, right? We're going to help out the fetch results controller here. Now we have one additional change we want to make in the self row at index path function, and that's we're going to change this task.subtask to this task.subtask lower t here. When we did our task model before, we used a capital T, and now we're going to use a lower t because that's what we use in our task model when we set up our attribute. So it's just a little bit different. Same thing otherwise, though. We're still doing this task.task, this task.subtask. So we've been able to use this fetch results controller, much like our base array. We've actually just had to use number of objects and object at index path. These are slightly different, but it's a really cool way that we can grab all this information and manage all this information that's being stored without having to create this base array, append things to our base array, remove things from our base array. It's a lot cleaner to do, and we're going to see as we continue making revisions just how clean it is. Now we have two additional updates we want to make to start fixing all of these errors we have. So let's jump over to commit editing style, and we see that we have a bunch of errors here. And that's because we're using the base array. So the first thing is we want to update the way we're getting the task. And hopefully this will seem a little bit familiar now that we've done this one. So we're going to do fetch results controller dot object at index. And we're just going to pass in our index path. And we're going to specify that this is a task model. So this is the same thing we just did. Instead of doing base array and figuring out the section and then figuring out the row, we're just able to pass an index path and get back a task model instance. And we specify that what we're getting back is a task model instance. We're only getting one type of entity back from our fetch results controller. The second thing we want to do here is we want to just update our tasks so we can actually just remove all of this code here. And this is what I mean by just being a lot cleaner. We're going to be able to say this task.completed equals true. And then we can say this task.completed equals false. And then instead of having to write these two lines of code here, which is the reload and updating the base array, all we have to do here is say UI application dot shared application dot delegate as app delegate. This is the way we've gotten the app delegate in the past, and we're going to call the function save context. And this is just going to save whatever changes we make to our entity here. So it's super clean. We see that we were able to cut out a bunch of lines of code and just make this way simpler. So it was a little bit more setup work, but super simple. Now, one thing we did remove here was the idea of reloading the data. So we actually have this super cool way we can reload data now. We're going to add this function. It's going to be controller did change content. And we get this function because we conform to the NSFetch results controller delegate. And when we set the delegate property equal to self, this function will be called automatically when we make changes to our entities. This function will automatically be called, and it will know to update the information in our table view. How will it know to update the information in our table view? Well, we're just going to type in tableview.reload data. So the idea here is if there are changes to our entities, we want to update the information in our table view. So this function will get called, and then we'll be able to upload or reload our table view each time. So let's just also add a comment here. We're going to call this our NS fetched results controller delegate. So we have a few more bugs to fix in our computer program, but we've really started to implement our NSFetchResults controller, and we're starting to see just how clean our code becomes when we're using this thing. We're now going to go ahead and update the prepare for segue function inside of the viewController.swift file. And once again, we're not going to be using the base array. We're going to be using our fetchResults controller in order to get the task back. So we're going to be able to say fetchResults controller.object@index, and we'll just pass in index path. And we have to specify that this is a task model. So this is exactly what we've done twice in our last video. So we're accessing, we just need to add an exclamation point. This is an optional. So we're going to say fetchResults controller.object@index, and we're going to pass in our index path. In this case, it's an optional, so we add our exclamation point to unwrap it. And it's going to give us back the correct task model instance, and we're going to specify that it's a task model instance. Now, there's a little bit of additional refactoring we want to do, and we'll start with our detail view controller. We no longer need to pass the main view controller because we no longer need to do updates to the base array from our detail view controller. So we can just remove this line of code here. And to keep our code clean, let's also go over to the task detail view controller and just remove the main VC property as well. We don't want that. And then let's do the same thing for the add task view controller. We're going to remove this setting of the property. And in our add task view controller, we'll also go ahead and remove the main VC property as well. So this will kind of clean up our prepare for segue function, as well as remove some extraneous code that wasn't causing any bugs, but was no longer needed. We have one more major item of refactoring to do, and that's going to be in our task detail view controller. And we're going to start by updating our viewDidLoad function. Let's just switch this to subtask, the lower t here. And then what we're going to do is we're going to update our done bar button item pressed. So the first thing we're going to do here is we're going to remove our code here that we're no longer using. And we want to create an instance of our app delegate, or we want to get access to the instance of our app delegate. So we're going to say let app delegate equal UI application dot shared application dot delegate as app delegate. Just getting access to the instance the way we've done. And then we're going to say detail task model dot task is equal to task text field dot text. And then we can say detail task model dot subtask is equal to subtask text field dot text. Detail task model dot date is equal to due date picker dot date. And detail task model dot completed is equal to detail task model dot completed. And let's save this. So we're going to say app delegate dot save context. Make sure you use the lowercase a. We want the constant and not the actual keyword here. And what is this doing? Well, we're just updating the detail task model instance. We don't need to create a new one. We're just going to use the same entity instance here. And then when we make our changes based upon whatever the user is doing, we'll just call save context. So our detail task model is going to be passed in automatically when our prepare for segue function in the view controller is called, right? So we had already called this task model. So our computer program just switched the task model from being our class, and now we're going to be, or I guess it was a struct, over to our entity here. So we're able to pass this in still. We're still able to update this. The only change we had to make was using the lower t, since detail task model is a task model instance, and it's now subtask as the attribute with a lowercase t instead of a capital T like we had with our struct. And we didn't have to create anything new. We just updated each of the elements for our detailed task model with the information from our text fields and our due date picker. And then we just called save context to save all of the changes we make, or all the updates to our task model instance, to core data. It's time to finish the last bit of refactoring and to do one additional update so we can have two sections in our table view. Right now we only have one. So how are we going to do that? Well, the first thing we need to do is we need to clear out our viewDidAppear function. And you might say, whoa, I spent all this time figuring out how to do sorted. Well, actually our fetch results controller is now going to handle doing sorting, right? Because we were able to do and then a sort descriptor. If we take a look down here, we were able to use a sort descriptor here for our date. So we no longer have to do this functionality to figure out how to sort our array. And we're no longer going to be able to do reload data here, or we no longer need to, because once again, our fetch results controller is taking care of that. Controller did change content. So we don't want to call reload data more than we need to, so we can just go ahead and clear out view did appear. Now, we do want to add one additional sort descriptor. I mentioned that this was an array before, and we only started off with one sort descriptor to keep it a little bit simple. But we need one more, and that's the idea that we need to add a completed sort descriptor. So we're going to say let completed descriptor equal, and we're going to say this is going to be equal to an ns sort descriptor, and the key will be completed, and it will be ascending. So we'll set that equal to true. And then we can add this to our fetch request.sort descriptors, which is an array, which means that we can add two sort descriptors here. So let's add our completed sort, or completed descriptor, comma, our sort descriptor. So this will add both of our descriptors here. And we also need to make one additional change, and that's going to be we're going to add a section name key path. And this is going to essentially allow us to have two sections, and we're going to specify, okay, how many sections do we need? Well, let's make this based on completed, right? And completed can only be in two states, true or false. So it'll know to add two sections to our table view, right? So it's going to look at all the possibles here. So now we're not only sorting by completed, but we're also adding a second section name key path here, and it's going to allow us to have two sections. And we can go ahead and run our application here to do some testing to make sure that our application works. And I know we've done quite a bit of code here. We see it's currently empty. So let's try adding a task here, task 1. We'll say subtask. And let's set a date here. Let's add an additional task, and we'll say this should be our completed task. And we'll just say subtask. Not really worrying too much about this items, but let's switch this down to be completed. We now see our completed section appears, so that's working properly. The other thing we want to check is for persistence. So let's go ahead and press the stop button here and rerun our application. And we now see that our items are reappearing. So our changes we were making are being persisted properly. Now, the final thing I want to show you, if you get some error in core data, you want to refresh, or you just want to make sure that your items, you want to clear out all the old items, you can just press the stop button, hold down on your app, and just delete this. You would delete an app, like an app you would delete from your phone. Press delete, and when you rerun your application here, you'll see that you'll start off with no items. So it's often the case when you make changes to core data, you want to just clear it out, delete it. If you get some random crazy bug, you can always try doing that as well. It's a really good way to kind of refresh your core data stack and make sure that everything's fresh and clean in there.